Hey, welcome to Draft Academy. My name is Mike. In this course, I'm going to teach you guys everything you need to know to get started using C#. Now, C# is an extremely powerful programming language, and it's used in millions of applications around the world. There are literally thousands of things you can do with C#, and there's tons of different applications for this language. It's extremely powerful, and I'm excited to be bringing you guys a course that will teach you everything you need to know to get started. So we're going to start the course with the basics. We're going to install C#. We're going to install a text editor called Visual Studio. We're going to get everything set up, and we'll start writing our first program. I'm going to teach you guys the basics of programming. So we're going to look at some of the core programming concepts, things like working with data, variables, data types, getting input from users. Then we're going to move on to some more advanced stuff. We'll talk about things like loops and if statements and different data structures. And finally, we'll talk about some object-oriented programming concepts, things like classes and objects, inheritance, all that fun stuff. If you're new to programming or you just want to try and pick up C#, then this course has something for you. I'm really excited to be bringing you guys C# tutorials. It's an awesome language, and there are literally thousands of things you can do with it. So without further ado, let's get started. Let's go into the course and start learning some C#. In this tutorial, I'm going to show you guys how to install and get everything set up to start programming in C#. Now, in order to start programming in C#, we're actually just going to need one thing, which is going to be a program called Visual Studio Community. And this is basically a program that will allow us to write our C# programs. And this is what's called an integrated development environment. And a lot of times you'll hear people call those IDEs. It's essentially just a special program where we can write and work with our code. So in this case, this is an IDE that will allow us to work with the C# programming language. So I'm over here on this website. It's just visualstudio.com/vs/community. And this is the website where we can go to download this. You'll see over here there's an option to download on Windows, and then there's also an option to download on Mac over here. So you can just click whichever one you need. In my case, I'm on a Windows, so I'm just going to go ahead and click the one for Windows. So I'll click this, and that should start downloading in. We should get an installer that we can use to install Visual Studio. So once that's downloaded, I'm just going to click it, and we'll go ahead and run this installer. So when the installer loads up, you'll see that we have this little window over here, and basically this is a little program that we can use to install what we need. Now here's the thing, this Visual Studio program is huge, and there's tons of stuff that you can actually do with it. So you can see there's all these different things we can install. I mean, there's probably like over 100 gigabytes worth of stuff that we could install here. We basically just need this guy over here. It says .NET Desktop Development. This is all we're going to need. We're going to be building something called a console application, which is essentially like the simplest type of application that we can build. And you'll see over here, it says the install size is around 3 gigabytes. So that's actually not too bad. Some of these things are like a couple, maybe like a dozen gigabytes or something like that. So yeah, click this .NET Desktop Development, and I'm just going to click install, and we're going to go ahead and install that. Hopefully it doesn't take too long. All right, so once that is finished installing and downloading, we can just go ahead and click launch, and we can launch right into Visual Studio. And you'll see over here, it's asking me to sign in. You don't actually have to sign in, so I'm just going to click not now, maybe later. And then over here, we have a bunch of options. You'll see down here, there's this drop down. I'm just going to click general, so just make sure it's on general, and then we can pick whatever style we want to have. We can just go with the basics, so I'll just stick with blue, and then I'm going to click Start Visual Studio. All right, so this should go ahead and open up this little starting page. I'm just going to click out of this. We don't need to have this up here. And I'm going to go over here, and we're just going to click File, and I'm going to click New Project. So we want to start a new project. And this is basically going to allow us to write our applications. So over here inside of Visual C#, you can just click here, and you'll see over here there's an option for console app. This is what we want. So don't get too intimidated by all this different stuff. Like I said before, Visual Studio is a very powerful program, and it can do a lot of stuff. But make sure you just click console app, and we should be good. So I'm just going to click OK. And actually down here we could give this a name. So I'm just going to call this draft, and then we could store it wherever we wanted to store it. So when this loads up, you'll see that we now have this file open, and this is just called program.cs, and that .cs extension stands for C#. And then down here we have a basic program. So this is essentially a very simple program, and it's sort of like the template for a program. And don't worry too much about what all this stuff is. In the next video, I'm going to talk you guys through what all this stuff is, what it means, and we'll actually write our first program. But for now, we have everything set up, so we're ready to go and ready to get started with C# development. In this tutorial, I'm going to show you guys how to write your first C# program. We're also just going to talk in general about what a program is. So we're going to look at the different instructions that we can give to the computer and how those instructions are going to play out and allow us to write applications. So over here, we basically just have our basic project set up, and I kind of went over how to do this in the last tutorial. And we're basically given this little text file, and this is a C# file. So it's called program.cs, and that CS extension stands for C#. You'll also notice over here in our Solution Explorer, we have a bunch of different stuff here. So I called my project Draft, and then over here I have like this little properties thing, this references thing. Really all we need to worry about over here, and I know there's a lot of stuff over here, is this guy right here, program.cs. That is the C# file that we're going to be programming in. That's the file we're going to be using for this course. And this is really all you need to worry about over here. And you'll see that this is actually populated with some code, with some text by default. You'll see up here we have all of these little commands. It just says using system.collections, all this stuff. Essentially what this is doing is it's just configuring the file, so you don't really have to worry too much about what this stuff is up here. Just make sure that you leave it alone, don't touch it. But basically there's some things that we're gonna have to use with C#, and up here we can specify that we want to use them. So there's these things called system, and there's all these different things that we can use inside of there. But for the most part, you can just kind of leave this alone for now. We'll talk more about what this is later in the course, but for now you don't have to worry about it too much. Down here you'll see this says namespace draft. You'll notice that this is actually the same name as the project that we're using, and essentially that's what this is saying. It's saying that we're in the draft project, and actually this is doing some more stuff. Again, we're going to talk more about namespaces later in the course, so you don't really have to worry about that too much. And really, all the stuff up here you can kind of just leave alone. You don't have to worry about that in the beginning. And down here we have these two curly brackets, and these two curly brackets essentially just signify that our program is starting. So inside of these curly brackets we can actually write some code, and the computer will be able to execute that code. Here we have this keyword class, and it's called program. Now a class is essentially just a container where we can store a bunch of code. So inside of a class we can write all of the code for our program, and it'll be able to be executed. So again, we're going to talk more about classes as we go on through this course, but for now just know that a class is essentially just a container where we can put code. Down here we have this line of code here. It says static void main, and this is actually what's called a method or a function. Again, we're going to talk more about methods and functions later in the course, but this is sort of just like another container where we can put code. And this is a very important container because this container is where we can put all the code that we want our program to execute. So this main method or this main function, any code that we put inside of here, in other words, any code that we put inside of these open and closed curly brackets is actually going to get executed by our computer. So whatever code I want my program to have, I need to put it inside of this main method. So inside of these open and closed curly brackets. Now, I understand that a lot of this stuff doesn't make sense right now, and to be perfectly honest with you, we kind of have to just set our program up this way in order for it to work. It doesn't matter if this stuff doesn't make sense. Obviously you're not going to understand what all this stuff is, but just know that that's totally fine. As a beginner, you're not expected to know any of that. You're not going to know any of that. Through this course though, I'm going to be teaching you guys all of this stuff. So by the end of the course, we'll understand what all this stuff is doing, why it's important, why it's there. But for now, I just need you to trust me that we need to have everything set up like this in order for our programs to run. And any code that we're going to write inside of our C# file that we want to execute, I want to put in between these two curly brackets inside of this main block. Okay. So now that we've kind of talked about the structure a little bit, we've talked about some of the stuff that we needed to know, what I want to do is actually write our first line of code. So we're going to go ahead and write a line of code which is going to print something out onto the screen. So one of the things that is really useful to do when writing a program is to print out information. And the most basic instruction that we can give the computer is basically telling it to print something out. So I'm going to go ahead and do that. Down here, we're going to write our first line of code. So I'm just going to say console with a capital C dot write line. And then I'm going to make an open and closed parentheses, and I'm going to make a semicolon. Now, inside of these open and closed parentheses, I'm going to make an open and closed quotation mark, and I'm just going to type out hello world. So essentially what we're doing here is we're telling C# that we want to write this text out onto the screen. So let's kind of look through this line of code. I'm saying console.writeLine, and this is an instruction. So essentially I'm telling C# that I want to write a line out onto the console. And as you'll see in a second, the console is basically just a little window where we can see the output of our program. I'm saying console.writeLine, and inside of these parentheses, I'm specifying what I want to write out onto the console or out onto the screen. And I'm basically just saying hello world, and then over here I'm putting this semicolon. Now, whenever we're writing a line of code in C#, whenever you're done writing that line of code, you always need to end it with a semicolon. So for the most part, whenever you write an instruction, whenever you write a line of code, you're going to end it with a semicolon, and that's very important. And as a beginner, you're going to forget to put the semicolon. Trust me, everybody does, but eventually you'll just kind of get used to putting it in there. All right, so I'm going to go ahead and save this file, and now we're going to actually execute this program. So when I say execute the program, essentially what I'm doing is I'm telling the computer to go through and carry out all of the instructions that we specify. In our program right now, we only really have one instruction, which is telling the computer to write a line out onto the console. I'm going to come up here and you'll see there's this start button. So this is going to be our best friend throughout the course. Anytime I want to run my program, I'm going to go ahead and click this start button. So I'm just going to click it. And when I click this start button, my program is actually going to run. And if you look there, you'll see that a black window popped up for just a second. I'm continuing to run it. Essentially what's happening is C# is printing out the line hello world onto a little console window that's popping up. But the problem is that our program is printing that out and then the program is terminating, so that window is going away. In order to keep that window up so we can see what's going on, I'm going to type out another line of code. I'm just going to type console.readLine. And basically what this line of code is going to do is it's going to keep that little console window up until I enter in a line of text. So now when I run my program, you guys will see that this little black window up here appears and then it stays open. So before it was kind of flashing up and then disappearing, but now it's going to stay open. And you'll see we're printing out hello world onto the screen. Now, if I click the enter key, so I'm just going to click enter, this window is going to go away. So anytime I click enter, that basically tells our program that we're done executing it, so we want it to go away. And that's basically all we have to do. So I can write out instructions in here. I can write out lines of code. I can press the start button, and then I'm basically executing all of those lines of code. And then obviously to get out of this, like I said, you can just like type a space and type enter, or you can really type anything and just hit enter, and then the program will terminate. This is sort of our first C# instruction. And like I said, console.writeLine basically just writes a line of text out onto the screen. And then we can include this console.readLine instruction in order to keep that window up so we can see what we're printing out. Now that we know how to print out something onto the screen, I want to show you guys how we can draw a little shape. So I'm actually going to get rid of this, and I'm going to go ahead and copy this WriteLine piece of code, and I'm going to paste it a few times down here. So we're actually going to use this line of code to draw out a shape onto the screen. So down here I'm going to create like a /, and then up here we'll create one, and I'm going to keep creating them in this little pyramid structure. So now you can see I have like a little pyramid, and then I'm going to make vertical bars going all the way down. So essentially we're drawing out like a little right triangle. And actually, you know what, I'm going to put underscores here so it's a little more obvious. So you can see I'm saying console.writeLine, and in each one of these instructions I'm telling the computer to write out a different line. So over here we're writing out like the tip of the triangle, over here we're writing out the middle part of the triangle, and then the base of the triangle. So now let's go ahead and run this program, and you'll see over here we're actually able to print out this entire triangle. So just by using that one instruction, that console.writeLine instruction, I was actually able to draw out an entire shape onto the screen. So now I'm going to go ahead and exit off of this, and you'll see down here how easy it was for us to write this program. Now, essentially what happens is when I click that start button, C# is going to go into my program. It's going to find this block of code right here, main. It's going to go inside of these curly brackets, and it's going to execute each instruction, in other words, each line of code, one after the other. So it's going to start with this first line of code, and it's basically going to say, okay, what does the user want me to do? They want me to write a line out onto the console, and they want me to write this text. So it's going to go ahead and write that out onto the console. Then when it's done with this instruction, it's going to come down here and go to this second instruction. It's going to do the same thing. It'll execute that instruction. And then it'll go down here, execute this one, and execute this one. So essentially what C# does is it executes all of the lines of code, all of the instructions that we give it in order. And one of the things you're going to learn is that when we're programming, the order matters. So the order in which you write these lines of code actually matters a lot. So if I was to take this instruction over here and I was to paste it up here on the top, now this is going to change the way that the shape looks. So instead of having that normal triangle, you can see we have this kind of like funky looking shape where the base is up at the top. And that's because we changed the order of the program. And essentially all a program is just a set of instructions specified in a particular order. That's it. And as we go through this course and as you learn more about C#, you're going to find more and more complex instructions that you can use. So the more complex instructions you're able to give the computer and the better you're able to organize them and order them, the more powerful your programs are going to become. So obviously we only really know two instructions. We know this console.write line, which prints something out, and console.read line, which basically pauses the screen until we enter something. But just with these two lines of code, we were actually able to draw out an entire shape onto the screen, and that was pretty cool. The takeaways from this tutorial is that a program is essentially just a set of instructions that the computer is going to follow. The order of those instructions matter, and in C#, the instructions that are going to get executed by the computer are going to be inside of these open and closed curly brackets in this main block of code. And that's sort of the bare basics of writing a C# program. You know, we were able to print something out onto the screen. We were able to pause that little console until we told it we were done. And now we can kind of go forward and start learning more and more complex instructions and more complex ways to build our programs. In this tutorial, I'm going to talk to you guys about variables in C#. Now, a lot of times when we're writing programs in C#, we're going to be dealing with a bunch of different data. So there's going to be all sorts of information, all sorts of data values in our programs. And a lot of times that information, those data values, can be kind of hard to keep track of and manage. So in C#, we have a special container called a variable. And a variable is basically just a container where we can store some of that information. So I could store a piece of data or a piece of information that I want to keep track of and manage in my programs inside of a variable. So in this tutorial, I'm going to show you guys what variables are, why they're useful, and we'll look at kind of how we can work with them in our C# programs. So down here, I have written out this very basic program. It's basically just writing out a bunch of lines of text. It says, there once was a man named George. He was 70 years old. He really liked the name George, but didn't like being 70. So this is basically just a program that I wrote which prints out a little story onto the screen. So if I was to run this program, you'll see that we get this story. It says there once was a man named George, he was 70, etc. So I'm able to print out this story onto the screen. So this is a perfectly functional program. We've actually written a program which prints out a story, right? But let's say that I'm looking at my story and I'm thinking to myself, I think I want to change the character's name. Well, let's say instead of having the character be named George, I want to change his name to John. Well, I can just come up here, I can search through my story and find every place where I'm mentioning the character's name, and I can change it to John. Cool, so now my story is updated. I went through, I manually changed the name to John, and everything works. But let's say I'm looking at it again and I'm thinking, maybe I want to try to appeal to a younger audience. So instead of having the character be 70, why don't we have the character be like 35? So once again, I can just go through, I can look through, and every time they mention the character's age, I can just change it to 35. Here's the next one. Cool. So I basically went through and I found out every place where the character's name was mentioned, and I changed it to 35. Here's the problem though. In order to make those changes, in order to modify the character's name and the character's age, I had to go through and manually change it at every place inside of my program. So every place where the character's name was mentioned and the character's age was mentioned, I had to go in and manually change it. Now, this is fine with a story that only has 4 lines, but imagine if this story had hundreds of lines and the character's name was mentioned like 100 times, or their age was mentioned 100 times. Imagine then if you wanted to change the character's name, or imagine even if you just wanted to keep track of and manage the character's name, and it would be extremely difficult. So the more lines in this story that I write, the harder it becomes for me to manage the character's name and the character's age. And these are 2 good examples of pieces of information in our program. In order to make a situation like this a lot easier, we actually have something in C# called a variable. And a variable is basically just a container where I can store a specific data value. And then when I want to use that data value, instead of having to actually like type it out and type out what it is, I can just refer to the variable's name. So I'm going to show you guys how we can create variables and how we can keep track of and manage the different data in our programs, like the character's name and the character's age. So up here above my story, I'm actually going to start creating a variable. And the way that we can create a variable is by giving C# some information. So this is going to be a line of code, and the first piece of information that I want to give to C# is going to be the type of data that I want the variable to be able to store. So remember, variables are just containers that we can store values inside of. And different containers can store different types of information. Some containers can store text, others can store numbers, others can store like other values like true or false values. We're gonna go ahead and create a variable that's gonna store the character's name. So I wanna create a variable that can store text, because the character's name is text. And we can do that by creating a string. So a string is essentially just like a string of characters, and it's basically just plain text. So I'm gonna go ahead and tell C# that I wanna create a string variable. So I'm just gonna type out string. And then what I need to do is give this variable a name. So remember, these are containers. And generally, when we're naming a variable, we want to name it according to what's gonna be stored inside of it. That way we can identify what's in the variable. I'm just gonna call this character name. And you'll notice here that I'm separating these words so the second word has a capital letter. All right, so I created my variable and it's gonna store a string, which is just plain text, and then I'm gonna set it equal to something. So I'm gonna say character name is equal to, and now I'm gonna give this a value. So I'm gonna give this a value that's plain text. I'm gonna make an open and closed quotation mark, and then whenever I write a line of code, I always want to end it off with a semicolon, just like that. All right, now inside of these quotation marks, I can write out the string of characters or the string of text that I want to store inside of the character name variable. So we're just going to store the character's name, which is John. So I can just type out John up there. In addition to creating a variable to store the character's name, I also want to create another variable to store the character's age. So let's go ahead and do that. Now the character's age is actually going to be a number, right? So the character's age is a number. It's not really plain text like this. And if we want to create a variable to store a number, we can create a variable called an integer variable. So int stands for integer. And an integer is basically just a whole number. So a number that doesn't have decimal points. And I'm just going to go ahead and name this character age. So again, giving it a name, and I want to show you guys another way that we can create these variables. So in addition to saying like string character name is equal to John, I could also just say int character age. I could put a semicolon here, and then I could come down here and give this a value. So I could say like character age is equal to, and now we can give this a value. So we said 35. And you'll notice that when I give this a number value, I don't need these quotation marks. You only need the quotation marks with a string. So these are 2 different ways that I can create a variable, and they're doing exactly the same thing. Up here, I'm just saying string character name, and I'm giving it a value right away. Over here, I'm doing what's called declaring the variable. I'm basically saying that we're going to have a variable called character age. I'm not giving it a value right away. And then down here, I'm assigning it a value of 35. So these 2, this guy and this guy up here, are doing exactly the same thing. So now that we have these variables, in other words, now that we have containers where we can store the different values or the different pieces of data that we're going to work with in our programs, I want to actually use those variables inside of our story. So I'm going to show you guys how, in addition to printing out this plain text, I can actually print out the value that's stored inside of the variable. So over here, you'll notice that I'm typing out there once was a man named John. But I don't want to have to type out John anymore. I just want to be able to refer to that variable. So what I can do is I can actually get rid of this, and I'm going to come outside of these quotation marks, and over here I'm going to put a plus sign. And this plus sign basically means I want to like append some text, or I want to append a value onto the end of this text over here. And what I want to do is just put the name of the variable. So I'm just going to type out character name. And what this is going to do is it's going to print out there once was a man named, and then a space, and then it's going to print out the value that's stored inside of the character name variable. So it's going to print out John. So let me demonstrate that. Let's go ahead and run this program. And you'll see over here, we're still printing out there once was a man named John, except I didn't have to physically type out John down here. All I did was use this plus sign and essentially just append on, or people will call this concatenate on, the value that was stored inside the character name variable. And this is extremely useful. So I could do the same thing down here with this other occurrence of the character's name. I can just say character name. And now over here, it's going to do the same thing. It's going to say he really liked the name, and then whatever the value that's stored inside of this character name variable. We can do the same thing for the age. So over here, you'll notice that I have the age is 35. But remember, we created this variable up here to store that. So what I can do is I can actually get rid of this, and I'm actually going to make two open and close quotation marks here, and I'm going to make two plus signs, and then in between here, I'm going to type out character age. Essentially what I'm doing is I'm telling this right line instruction that I want to print out he was with a space, and then I want to add in the value that's stored inside of the character age variable, which is going to be 35, and then I want to add into that years old. So basically what we're doing here is called concatenating a string. I'm saying I want to type this out, plus I want to type the value that's in here, plus I want to print out this stuff over there. And then finally we can do the same thing down here. So I'm going to get rid of this, and I'm just going to type in character age. So I've replaced every occurrence of the character's name and the character's age with these variables. So now let's go ahead and run our program. I'm just going to click this start button, and you'll see over here we're printing out the same exact story as before. It says there once was a man named John. He was 35. He liked the name John, and 35. So I essentially just replaced John and 35 with the variables that are storing them. Now, what's cool about these variables is if I wanted to, for example, modify the character's name or the character's age, I can just modify it up here. So let's say we wanted to change the character's name to Tom, and we wanted to make him like 25. Well, now I only have to modify those two values. I only have to update them in one spot, and it's going to update throughout my entire story. So now the character's name is Tom, and he's 25 throughout the entire story. And the variables just make it a lot easier for us to keep track of and for us to manage those pieces of information. Now, you'll notice that I only created variables for the character's name and for the character's age. And that's because those two pieces of information are occurring multiple times in the story. I didn't create a variable for the word once or for the word man because I just didn't need to. You know what I mean? That's not like a distinct piece of information that we want to keep track of. But the character's name and the character's age are definitely pieces of information that we're going to want to keep track of and store. So that's sort of how we can use variables to make it easier to manage the data in our programs. Now I want to show you guys another cool thing we can do with this. Let's say that halfway through the story, I wanted the character's name to change. I could actually come down here and halfway through printing out the story, I can modify the value of one of these variables. So I could say character name, and I could just give this another value. So I could say character name is equal to Mike. And again, I need this semicolon at the end here. Don't forget that. Now, halfway through the story, the character's name is actually going to change. So if we run the program, you'll see over here it says Tom, and then down here, the name is Mike. So I was able to update the value that was stored inside of our variable halfway through. And that's another cool thing is these variables, you can give them one value, and then later on in the program, you can change that value. So that's really the basics of working with variables. We really learned two things. We learned how to create variables, and we learned how to use them inside of like a print statement over here. Now, there's a lot more to learn with this. And actually, in the next tutorial, I'm going to be teaching you guys about the different types of information that we can store inside a variable. So over here, we stored a string of text, and we also stored a whole number, which is called an integer. But there's a few other types of data that we can use and work with. So in the next tutorial, we're going to learn about all of that stuff. In this tutorial, I'm going to talk to you guys about data types in C#. Now in C#, we're going to be dealing with all different types of data and information. And generally, when you're writing programs, there's going to be all different types of information that you're going to be working with. So I want to talk to you guys today about the different types of information and the different types of data that we can represent and work with in C#. So down here, I'm basically going to be showing you guys all the different data types that we can use. And I'll be doing that by creating variables. So a variable is just a container where we can store a data value or a piece of information. And I'm going to be creating different variables that can store the different types of data that we can work with in C#. So the first type of data that we can work with is plain text. So anytime you want to represent or use just regular old text inside of your programs, you want to use something called a string. So I'm just going to say string, and I'll just call it phrase, and I'm just going to set it equal to a string. So a string is basically just denoted using an open and closed quotation mark. And then inside of the quotation marks, you can just put whatever string you want to represent. So in here, I could put like Draft Academy. And now this is going to be a string with the text Draft Academy inside of it. So that's a string, and that's going to come in handy a lot. Another type of data that we can store is, instead of a string of text, just going to be one single character. So if I want to create a character, I can just say char, and maybe this could be like the grade you get on a test or something. And then when I create a character, I want to use these single quotation marks, just like that. And then inside here, I can put one single character. So I could put like an A or a B or a C or something like that. But the important difference is that with a character, I can only put one single character. I can't put a bunch of stuff. I can only put one. So any single character is going to work, but you need to make sure that there's only one in there. When you need more than one character, then you want to move up to the string. All right, so that's the two ways we can store plain text, so things like characters and strings of characters. We can also work with numbers, and the most basic type of number we can create is called an integer. And an integer is basically just a whole number. So it's one of the counting numbers, like 1, 2, 3, 4, 5. Basically, an integer doesn't have any decimals in it. So I can just say int like that, int, and this could be like someone's age, for example. So maybe someone's like 30. And you'll notice that when I create a number, like any numbers or, whether it's an integer or another type of number, you don't need quotation marks around it like you do up here. So you can just type out the number as is. And you can do whole numbers like this, like an integer. We could also do negative numbers, and you can just put the minus sign right in front of it. And C# is going to be able to handle negative numbers just fine. So in addition to integers, we can also represent decimal numbers. So a decimal number would be, like 60.3 or something like that. And instead of storing it inside of an integer, we can actually store it in one of 3 data types. So there's actually 3 different data types that we can use to represent decimal numbers. And they're called, there's a float, a double, and a decimal. And these basically allow you to store decimal points more and more specifically. So these range from least accurate with the float to most accurate with the decimal data type. So if you really want to be super, super, super precise with the decimal point that you're using, you want to use a decimal point. And this would be used for things like money or, really anything that you need to be extremely exact with, you want to use a decimal. A float is going to be less precise, so it's going to be able to be taken to a less precise amount of decimal places. And then double is kind of just like right there in the middle. For the purposes of this course, I think for the most part, we're just going to be using a double. I think for most use cases, a double is going to be just fine. But like I said, if you're doing something, where you need to be extremely accurate, like with money or something, then you want to use that decimal. So I can just say double, and I can give this a name. So we could make this like a GPA, right? Someone's GPA might be like a 3.2. And so this is a good example of a decimal number. You could also make these just normal numbers. So I could make it like 3.0. But anytime I'm using a decimal number, I need to include this 0.0 in there. So that's integers and doubles. And those are the 2 main types of, like I said, numbers we're going to be able to represent: whole numbers and then decimal numbers. And then we kind of touched on like the different types of decimal numbers. So after characters and numbers, we just have one more like core data type that we're going to be representing, which is going to be called a Boolean. And a Boolean is essentially just a true or a false value. Now, a lot of times in programming, we're actually going to want to be able to store true, false information. And this might not be something that is super intuitive to you if you've never programmed before, but a lot of times storing information in the form of a true or false value is going to come in handy. So if I want to create a Boolean, I can just say BOOL, and Boolean is just it essentially just means a true or false value. So I can say BOOL, and I can give this a name. So we could call this like is male. And this Boolean will basically tell us whether or not someone is a male. So I could say true if we're a male, or you could also say false. But those are the only two values that this should have. It should either be true or it should be false. That's it. And that's basically why Booleans are useful, because they can only have two values. So for the most part, I would say these are the core data types that you're going to be using in C#. Now, there are a few other data types that we could get into. They're a little bit more obscure and they're not used as commonly as these data types. For the most part, you're going to be fine with just strings, characters, numbers, and then Boolean values. 99% of the stuff that you want to do, you're going to be able to do with just this data. And as a beginner, you only really want to concern yourself with these data types. Now, I do want to point one more thing out is you can represent these data types outside of variables. So if I came down here and said like console.writeLine, I don't have to like store this type of data inside of a variable if I don't want to. Like I could just print out like a string like hello down here. Like this isn't actually stored inside of a variable. Or I could print out like a number. Like if I wanted to print out 30, I could do that. And then when I run my program, you can see we printed out just fine. These are what we would call constants, and a constant is basically just like a value just like this, 30. It's not stored in a variable. We're not keeping track of it anywhere. It's just kind of written out. You can do the same thing for Booleans. So obviously you don't have to store this information inside of variables. A lot of times it's useful to do that, but if you don't want to, you can just kind of use it like that. So that's the basics of data types in C#, and these are going to come in handy a lot. Really, with just these types of data up here, you can write a bunch of awesome programs. In this tutorial, I'm going to talk to you guys about strings in C#. Now, strings are one of the most useful types of data that you're going to be working with in C#. So in this tutorial, I want to just show you all the ins and outs of working with strings. We're going to look at some of the cool things that you can do with them and how you can really leverage the power of strings inside of your programs. So down here, you'll notice that I just have this little console.writeLine instruction, and basically this is just going to write out some text onto the screen. So if I wanted to create a string, I can just make these open and close quotation marks, and then in here I could type out some text. So I could type out like Draft Academy, and now when I run my program, it's going to go ahead and print that onto the screen. So anytime that I want to represent some sort of like plain text or really any type of text in my program, I can do it with a string. And there's actually some cool things you can do with these strings. So let's say, for example, that I wanted to print out Draft Academy, but I wanted to print out Draft on one line and then Academy on the next line. I can use something called a new line character. So I could actually say \n, and this is a special character that we can use in C# strings, which is basically going to specify that we want to type out Draft, then a new line, then Academy. So now when I run my program, you'll see that Draft and Academy are printed out on different lines. So that can come in handy when you're writing out your strings. There's also another way. So let's say that I wanted to write out a quotation mark. If I put a quotation mark here, you'll notice that this quotation mark effectively ends this string, and then this over here is just causing an error. If I want to actually print out a literal quotation mark that's not, delineating the string, I can just use that / again, and now we'll be able to print out that quotation mark, no problem, just like that. So those are some cool little things that we can do inside of our strings. You can also take a string and store it inside of a variable. So a variable is just a container that you can store different pieces of information. So if I wanted, I could create a variable over here, just say string, and we can just call it like phrase, and I'm just going to set it equal to this text over here, which is just going to be Draft Academy. And then down here, I could just print out the value stored inside of this variable. So I could print out the value stored in the phrase variable, and we're still printing out Giraffe Academy. So that's kind of cool. Another thing you can do with strings is called concatenation. And concatenation is the process of taking one string and then appending another string onto the end of it. So you're essentially just adding two strings together. So for example, over here I could say string phrase is equal to Giraffe Academy, and then I could use this plus sign, and then this is basically going to add another string onto that. So I could say like is cool. And now when I print out phrase, it's going to be printing out Giraffe Academy is cool. So it basically just added those two strings together. We would call that concatenation, and that can be really useful. Another thing we can do in our programs is find out information about our strings. So sometimes you might want to figure out different pieces of information about the string, figure out some attributes about it. So let's say we wanted to figure out how many characters were inside of this string. I could just say phrase dot length, and that's with a capital L. And now what this is going to do is it's actually going to tell me how many characters are inside of this string. So now we should get like 15. Yeah, because there's 15 characters inside of Giraffe Academy. So that's a really cool way we can find out some information about the string. In addition to finding out information, we can also use things called methods. And we're going to talk more about methods in a future tutorial, but essentially all you need to know right now is that a method is basically a little block of code that we can call, which is going to perform a specific task. So these are basically like little predefined snippets of code that we can sort of tell to execute, and then they'll do something. So we can use methods on our strings, and they'll either give us information about our strings, or they'll modify our strings in some way. So over here, if I want to use one of these string methods, I can just say the name of the string, or I could also type out like a literal string like that, and then I can just say dot. So I'm going to say phrase dot, and now I have access to all of these different methods. So if I want to use one, I can just type out the name of the method. And I'll show you, these can kind of do little things with our strings. So let's say that I wanted to take this string over here and convert it into all uppercase. Well, there's actually a method that's going to be able to do that for us. So I could say phrase dot to upper, and then I'm going to make an open and closed parentheses. And now this is actually going to take this string over here, convert it into uppercase, and then print out the uppercase string onto the console. So now when I run the program, you'll see we get Giraffe Academy all in caps. You can also do the same thing for lowercase. So I could say like to lower, and now it'll do the same thing. So it should all be entirely lowercase now, which it is. So that's one way that we could like modify the value of a string. We could also find out some more information about this string. So imagine we wanted to figure out if this string of text contained a certain like substring of text, right? So maybe we wanted to see if this string had the word academy in it. I could say phrase dot contains, and now what I'm actually going to do is I'm going to give this contains method a piece of information, and this is called a parameter. So this over here, this contains method will tell us whether or not this phrase string contains like a certain set of characters or something. And in order to use it, I have to tell it what I'm looking for. So I can say phrase.contains, and in here I could say like academy. And this is basically going to return a true or false value telling me whether or not the phrase Giraffe Academy contains the word academy. And we should get a true value back because it does. So you can see over here we get true. But if I said over here like academies, now all of a sudden we should get false back because that string is not included in the phrase string. It's not included in Giraffe Academy. And that can be kind of useful. You can like tell whether or not a certain string contains another string or another character. Another thing we can do is figure out the different characters inside of a string. So I'm going to get rid of that. Let's say that I wanted to figure out what the first character in my string was, right? So let's say there's a situation where I have a string like phrase, and I wanted to figure out what's the first character in that string. Well, I can actually access individual characters and print them out. So I could say like phrase, and I can make an open and closed square bracket. And inside of here, I can just put the index of the character that I want to print out inside of the string. So if I put a 0 here, this is going to tell me what this first character is. So phrase square bracket 0 should be printing out a capital G. And you see over here, it does. If I wanted to figure out what the third character in the string was, I can say 0, 1, 2. So I can say 2. And now this should print out that R for us. And you can see we get R. So if you haven't caught on by now, when we're indexing a string, we actually start at 0. So if I was going to assign index positions to each of the characters inside of this string, I would say that the G character is at index position 0, the I character is at index position 1, the R character is at index position 2, the A character is at index position 3, etc. So the first character, this G, is actually at index position 0 inside of the string. And that's basically just a way that C#, and actually a way that most programming languages index strings. So when I say phrase 0, this is actually referring to this first character. So let's see if we could print out this A over here. Well, it's basically going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be at index position 8. So if I put an 8 in here, now we should be able to print out that capital A, which we do over here. So that's sort of how string indexes work. And using this information, we can use another string method. So again, I'm just going to say phrase dot. And I want to show you guys another method that we can use. It's called index of. And index of is basically going to tell us not only if a string contains a certain value, but it'll tell us at what index position that value is located inside of the string. So for example, if I came over here and said academy, this is going to tell me at what index position academy starts inside of this string. So when I run my program, you'll see that we're getting an 8 over here. And we just sort of saw that that capital A character started at index position 8. So basically what this is saying is that academy starts at 0, 1, 2, 3, 4, 5, 6, 7, 8. So it starts here. In addition to passing in a string like that, I could also pass in a character. And remember, a character is just an open and closed single quotation mark. And then inside here, I could put like an F. And now this will tell me the location of the first F inside of this string. So it'll give me that index. And you can see we get 4. And that's because 0, 1, 2, 3, 4, this starts at a 4. And that can be pretty useful. There's also going to be the situation where the character isn't in there. So if I put a Z in here, you'll notice that there's no Z up here. And so in this case, we're actually just going to get a -1 back. And a -1 is always going to signify that the character is not inside of the string. So that can be pretty useful. So that's how we can use phrase.indexOf, and that'll come in handy a lot. There's also one more of these string methods that I want to show you, and it's called substring. So I can say phrase.substring, and I can make an open and close parentheses, and I'm actually going to need to give this a value. So basically what this will allow me to do is it'll allow me to grab a part of this string. So I could grab like one part of the string and then print that out onto the screen. And we can give this one parameter, we can give this one argument, in other words, one piece of information, and that's basically the index where we want to start grabbing the string at. So let's say that I only wanted to grab this academy word and print this out. Well, remember, academy starts at index position 8. We already saw that. So this capital A is actually index position 8 in the string. If I put an 8 in here, this is now going to grab the characters starting at 8 and going to the end of the string. So now we should just print out academy, which we do down here. You can also, in addition to just passing in the starting index, you can pass in a length. And you'll notice that I'm just using a comma here, and that's going to delineate that I want to pass in another value. So I'm passing in the starting index, and then I can also pass in how many characters I want to grab. So I can say I want to start grabbing the characters at 8, and let's say that I only want to grab 3 characters. So over here I can put a 3. And now we're going to start at 8 and we're going to grab 1, 2, 3 characters. So we should get ACA printed out onto the screen. And you can see that we do. So that substring method can come in handy. So that's kind of the basics of working with strings. And so I showed you guys kind of how we can work with them, different things we could do like concatenation, and we can also print out things like new lines. We also looked at getting information about a string, like the length and individual characters in the string. We talked about the string indexes. We also talked about different methods that we can use to do different things with our strings. So hopefully that kind of gets you up to speed with why strings are awesome and how they're useful. And to be honest with you, there's a lot more of these little methods that you can use. And if you want, you can just go online and Google C# string methods, and you'll find like a huge listing of probably at least a few dozen of these different methods that you can use to either find out information about or modify your strings. In this tutorial, I'm going to talk to you guys about numbers in C#. Now, numbers are one of the most common types of data that you're going to be working with in your C# programs. So in this tutorial, I just want to kind of give you guys a full walkthrough of how to use numbers, the different types of numbers that we can use, and we're also going to look at some cool things that we can do with numbers, things like complex math operations, and just dealing with numbers in general. So this is going to be pretty cool. Down here, I just have a basic program. It just is basically writing out a line of text. So if I wanted to, for example, like write out a number, I can just represent a number by just typing it out. So I could say like 40 or 20, or I could say like negative 5.763. Really any type of number I can work with. And there's really two main types of numbers. There's a whole number, which we would refer to as like an integer, and then there's a decimal number. So those two different types of numbers are going to be really useful in our C# programs. But it's important that you note that C# does distinguish between those two types of numbers. So there is a big difference between working with whole numbers and working with decimal numbers, and it's something that you just want to be aware of as you sort of go through and write your programs. And so, basically I could just type in a number here like 50, and then I'd be able to print it out onto the screen just over there like that. So numbers are pretty easy to work with. We can also do math with numbers. So I could say like 5 plus 8. And now instead of printing out 5 plus 8, like the literal text 5 plus 8, C# is actually going to go ahead and perform this math operation for us. So it's going to print out the result of adding 5 and 8 together, so we're going to get 13 over here. And we can use addition like that. We could also use subtraction, which is just that hyphen. We could use a /, which would mean division. And we could also use a asterisk, which is going to represent multiplication. So any of those different operations, the 4 basic math operations you can use. We can also use another operator, which is called the modulus operator. So for example, if I could say like 5, and then I can put a % sign here, and I could say 2, and we would read this as 5 mod 2. And this modulus operator right there, essentially what this is going to do is it's going to take 5, it's going to divide it by 2, and it's going to give us the remainder. So 5 divided by 2 is going to be 2 with a remainder of 1, and that's exactly what's going to get printed out. So we should just print out 1 over here, which we do. So sometimes you might be interested in getting the remainder of a particular division operation, and this is going to go ahead and do that for us. We can also represent like mathematical equations. So one thing we can do is specify order of operations. So if I was to say like 4 plus 2 times 3, actually what's going to happen is the multiplication is going to happen first, and then this addition is going to happen. So it's going to be 3 times 2, 6 plus 4, so we should get 10. And that's just sort of following normal order of operations rules. But if I wanted to change up the order of operations, I can use parentheses. So I could say like 4 plus 2, which is going to be 6, and now it'll be 6 times 3, so we're going to get 18 instead of getting that 10. So you can use those parentheses to sort of change around the order that different calculations are getting performed, and those can be pretty useful. I also want to talk to you guys about the difference between using integers and using decimal numbers. So like I said, an integer is just a whole number. A decimal number would be a number that has a decimal on it, something like that. And actually, like I said, C# does distinguish between these two types of numbers. So if you're adding or subtracting or multiplying or doing some sort of mathematical operation with an integer and a whole number, sometimes the results you get are going to be a little bit different. So if I was just to say like 5.0 plus 8.1, if I was to perform a math operation with two decimal numbers, then I'm going to get a decimal answer back. So I'm going to get like 13.1. But if I was to perform a mathematical operation with an integer and a decimal, so 5 plus 8.1, and you'll notice that this is now an integer because it doesn't have a decimal point, again, we're going to get a decimal back. So I'm going to get a decimal number back just like that. But when we do math operations with two integers, then we're always going to get an integer back. So if I said 5 divided by 2, and you'll notice that these are both integers, I'm actually going to get an integer answer back. So really this should be like 2 point something, right? It should have some long decimal point. But when I actually run my program, you'll see that I'm getting an integer value back. I'm getting a 2 back. But if I was to convert this to a double, so if I said 2.0, so now this is going to be a decimal number, we're going to get a decimal answer back. So that's basically how that works. So any math operation that you do with two integers, no matter what, you're going to get an integer back. But if you do a math operation with a decimal and an integer, then you'll always get a double back. And that'll kind of come in handy as you're working with these different types of numbers. Another thing we can do is we can store numbers inside of variables. So I could create a variable up here. Let's create one for int. So I'm just going to say int num, and I can give this a value of like 6, right? So now this container num is storing the value of 6, and then I could print that out just like I normally would. So I could just say num down there, and it'll print out that 6. There's another cool operation which we can do, which will basically allow us to increment this number. So down here I could say num plus plus, and basically what this is going to do is it's going to add 1 to the number. So now instead of being 6, since we're adding 1 to the number, this is going to be 7. So when I run my program, you see we'll get 7. And you can do a similar thing with minus minus. So I could say like num minus minus. And now instead of getting a 6, we would get a 5. And those are going to come in handy just as like a shorthand as we go through our C# journey. All right, so those are sort of the basics of, working with numbers, and you can see we can store them in variables, and we talked about, interacting between integers and decimal numbers. And I also want to show you guys some other stuff we can do. So a lot of times in our programs, we're going to want to be able to perform different math operations. So there's all sorts of math operations, like using exponents and using the square root, or even doing like logarithmic stuff or sine, cosine, tangent stuff. Like there's all sorts of math things that we might want to be able to do inside of our programs. And I'm going to show you guys, there's these things called methods. And a method is basically just a block of code that's going to perform a specific task. So I can do what's called call a method, and when I call a method, it's basically going to like perform a specific task or a specific function for me. And there's a bunch of these different math methods that we can use in our C# programs, and the way that we can get access to them is just by typing out math with a capital M, and then I can say dot, and now I have access to all these different math operations. So you'll see down here, I can like scroll down through this list, and there's all these different things that I can do. I'm going to show you guys a couple of these cool math methods is what they're called, and you can kind of see what they do. So one is just math.abs, and this stands for absolute value. So I can make an open and close parentheses, and inside of here, I'm going to put a number. So if I said like -40, this is going to give me back the absolute value of -40, which is just going to be 40, as you can see. There's another one which is called POW, and this stands for power. So I'm actually going to be able to give this 2 numbers, and it's going to spit out the first number taken to the second number. So if I said like 3 and then 2 over here, this is going to give me back 3 raised to the second power. So we should get 9, and you can see we do. And this will also work with like decimal numbers. So I could say like 3.8 raised to the second power, and now we should be able to run this as well. So 14.44. And you can also do the opposite. So we could say like SQRT. This is going to stand for square root. So if I put like a 36 in here, now I'm actually going to get back the square root of 36. So we should get 6 back. And we do. There's also another useful method which is called max. And with max, you can actually pass 2 numbers into these parentheses. So I could say like 4 and 90. And max is actually going to spit out whichever one is bigger. So it'll tell us which number is the biggest. And so this should give us 90, as you can see down there. And that can come in handy. There's going to be a lot of situations in C# where you might have 2 numbers. Maybe they're stored inside of variables, and you don't necessarily know which one is bigger. So you can use that math function to figure that out. There's also another one called min, and that just does the opposite. So now this will give us the smaller of the 2 numbers. So we're going to get 4 back. There's one more that I want to show you guys. It's called math.round, and this is a really great way to round numbers. So when I say math.round, I could pass this like a decimal number like 4.3, and this will round it just according to standard rounding rules. So you can see we get 4, but if I was to up this to like 4.6, now we're going to go ahead and get a 7 or a 5 back. So we get the 5 back there. So those are just some basic, math operations that you can do. And you can see I'm using this Visual Studio text editor. When I just say math and then I click this dot, you can see all of these different options are showing up down here. So there's all these different methods that we can call. I mean, there's all sorts of stuff we can do. And you can kind of just like play around with each of these, like see what they do. But for the most part, like any major math operation that you're going to want to be able to do, there's usually going to be a method for it, or at least a method in here to help you with it. So you definitely want to check that out. And you can also just Google like C# math methods online, and you'll find a huge listing of them. So that's sort of the basics of, using math and then also working with numbers. Again, numbers are extremely important. So you want to make sure that you're, up to date and sort of up to speed with how to use them and how they interact with each other and all that stuff in C#. In this tutorial, I'm going to show you guys how to get input from a user in C#. Now, one of the cool things about C# is we can actually have our programs interact with the user. So I could run my program and I can actually like give it some information, and it can use that information to do different things. And when you think about it, most programs that you probably use on a daily basis are going to allow you to input information into them, and then depending on the information that you input, they're going to do different things. So today we're going to look at the most basic form of that, which is just, allowing the user to basically like type in a value, and then we can use that value to do something. So down here I have a simple program set up. You'll see I'm just saying console.writeLine, and I'm writing out hello. And then down here, throughout this course so far, I've always included this line of code in our little programs. And basically what this line of code has been doing is it's been allowing us to see the output of our programs, right? So if I include this read line, when I run my program, then I can see what gets output. So I can see hello, right? It sort of stays on the screen. But if I was to get rid of this line, like if I remove this, when I click the start button, you'll see that that window like pops up really quick and then disappears. And that's because we're essentially executing this line of code, and then once that line of code's been executed, there's nothing else to execute, right? There's no other instructions for the computer to like carry out. So essentially the program just terminates, and then that window disappears. We've been using this console.readLine instruction in order to keep that black window up on the screen, in order to keep the console on the screen, because what this line does is it actually waits for the user to enter in a line of text. So this line essentially pauses the execution of our program and waits for the user to enter something. So if the user hasn't entered something, then our program is essentially just paused. So actually, if you guys watch over here, my program is essentially paused, but if I was to enter something and then click enter, the program terminates, right? Because now this line of code down here has finished executing. But what's cool about this line is, like I said, it pauses the program so we can sort of see what's happening. Another thing that this line of code does, though, is it allows us to enter in a line of text. And we can actually use this instruction over here to get input from the user. So I'm going to show you guys how we can do that. In this tutorial, I want to basically design a little application that's going to ask the user for their name. It's going to get their name, and then it's going to say hi to them. So I'll basically be able to type in my name, and then the computer will be like, hey Mike, what's up? So the way we can do that is with a couple steps. The first thing we want to do is prompt the user for information. So I'm basically just going to write out a line, and I'm just going to say console.write. And you'll notice before we were using console.writeLine. Now, essentially, the difference between write and writeLine is that when we say writeLine, this is going to print out a line of text, and then it's going to go on to a new line. So it's basically going to print out, and then we'll go on to a new line. When I just say console.write, it's not going to go off to a new line. It's just going to kind of print out on the same line. And you guys will see what I mean in a second. So I want to use console.write because I'm basically going to be prompting the user. So I can just say, enter your name, and then I'm going to make a colon. So this is going to be our prompt for the user. Now, the next thing that we want to do is we want to be able to allow the user to enter in a line of text. So I can do that, like I said, with console.readLine, just like that. And this is going to pause the program and wait for the user to enter in a line of text. But here's the thing. I don't just want to let them enter in the line of text. I want to be able to take the text that they enter and store it inside of a variable, right? Like if they just enter text, it's no use to me if I don't know what they entered. So I want to be able to store the value that they entered somewhere. And we can do that with a variable. So whenever we use this console.readLine, it's basically going to get the line of text that they enter as a string. So it's going to store the line of text that the user enters as a string of characters. So I'm going to create a variable, and we're just going to call this name, and I'm going to set this equal to console.readLine. So I'm saying string name is equal to console.readLine, just like that. Now the last thing I want to do is I'm actually going to write something out to the screen. So I'm just going to say write line, and over here we're going to print out hello, and then we're going to print out the name that the user entered. So I'm basically just going to print out hello plus name. So basically the user is going to enter in their name, and then we're going to say hi to the user. And you'll notice I'm keeping this read line down there just so we can see what the output is. So let's go ahead and run this program, and we'll see what happens. So over here it says enter your name, and you'll notice over here it's letting me enter this on the same line as this prompt, and that's why we use that console.write instead of console.writeLine. So over here I'm just going to type in my name. My name is Mike, and now when I click enter, the value Mike is going to get stored inside of that name variable, and then we're going to be able to print it out on the screen. So you can see down here we're printing out hello Mike. And that's essentially all we needed to do to get this program to work. So we used console.readLine, which paused the program and let the user enter in a line of text. When they hit enter, the value that they entered gets stored inside of this name variable, and then we printed it out onto the screen. So that's pretty cool. And we can actually do this as many times as we wanted. So if I wanted, I could get another piece of information from the user. So I'm going to do that. I'm going to copy this, and we'll come down here, and this time I'm going to ask them to enter in their age. So over here, we're going to create another string, and we're just going to call it age. And again, I'm just going to say console.readLine. So now, in addition to having their name, we also have their age. So I could say hello name, and then I can basically tell them how old they are. So I can say you are, and then we'll print out their age. So now we're saying hello, whatever the name is, you are, whatever their age is. So let's go ahead and run this program. Now we're getting two pieces of information from the user. So it says enter your name. So we can enter in like John, and let's say John is 40 years old. So now when I click enter, we're going to have two values, and we'll be able to print them out. So it says hello John, you are 40. So that's sort of the basics of getting input from the user. And again, remember what I said, when I use console.readLine, it's taking whatever the user enters and it's storing it as a variable. So this is always going to be a variable. It's always going to get the information that they enter as a variable. And that's why we had to store both of those pieces of information inside of strings. But there's actually a way that we can get other types of information like numbers from the user. And in the next tutorial, we're going to build a little calculator game, and I'm going to show you guys how we can actually get numbers from the user. But for now, that is sort of the basics of doing this. And you probably just want to practice with this and maybe make a little application of your own. In this tutorial, I'm going to show you guys how to build a basic calculator in C#. So we're basically going to build a little program where the user can enter in two numbers, and then our program will add them together and spit out the answer onto the screen. So it should be kind of cool. And we're also going to talk about getting numbers as input from the user. So this is going to be a pretty cool tutorial. So down here, before we start building this, I actually want to show you guys how we can convert a string into a number. And this is a technique that's going to come in handy for this application. Essentially, like if I had a string that had a number in it, so like 45 or like 45.80, what I could do is I could actually use a special method in C# that would be able to convert this into an actual number. And the reason that's useful is because like if I had console.writeLine, like if I had two strings that had numbers inside of them, like 43 plus 56, if I tried to add these two together, this is just going to concatenate the strings. So you'll see over here we get 4356. So it's not adding the two numbers that are in here together, it's just like concatenating the strings together. So in certain cases you'll have numbers that are kind of trapped inside of strings. And actually we're going to have that situation in this tutorial. And so you want to be able to get the numbers out of there so that you can like do math with them. So I'm going to show you guys how we can convert a string into a number. So actually over here, why don't we come down here and we're gonna make a number variable. So I'm just gonna make an integer and we'll just call this num, and I'm gonna set it equal to a string. So I'm gonna set it equal to a string that has a number in it, like 45. You'll see over here, C# is yelling at us because this number is actually a string. So it's not gonna be able to be stored inside of an integer variable. So we need to convert this into a integer. And the way that we can do that is just by typing out convert like that and with a capital letter and then dot. And now we need to specify what we want to convert. So you'll see over here, there's a bunch of options like 2int32, 2int16, 2 double, 2 decimal, 2 string. This little convert function is basically going to allow us to convert different values to other values. In our case, we want to convert this to an integer. So I'm just going to say convert.toInt32. And that was one of the options that we had over here. And then I'm going to make an open and close parentheses around the actual string. So when I do this, this is going to go ahead and convert the string inside of here into an integer. And just to note, the string that we put in here has to have a number inside of it. Like if this was just something like that, this isn't going to work. We're actually going to get an error. But if I have a number in here like 45, then this is going to work just fine. So if I was to come down here now, I could actually use this as an integer. So I could say num plus 6, and now we'll actually be able to do this math operation. So you can see we get 51. And that's essentially how we can convert a string into an integer. And just so I can point this out, like if this didn't have a number inside of it, or even if it did have a number inside of it, but the number had like text next to it, this isn't going to work. So we're actually going to get an error. And you can see the program wasn't able to run because it says down here, input string was not in correct format. So that's just something to keep in mind. And later in the course, we're actually going to talk about how we can fix something like this and mitigate it. But for now, we're just going to assume that the string is going to be formatted correctly. And I'm just going to exit out of this exception. All right, so that's kind of an explanation of how we can convert a string into an integer. And we're actually going to be able to use this in our program. So like I said, we're going to build a calculator program that's going to allow the user to enter in 2 numbers, and then we'll take those numbers, add them together, and print it out. So the first thing I'm going to do is just print out a prompt. So I'm going to say console.write, and I'm actually just going to use write. And then over here, I'm just going to say enter a number. And now we're prompting the user to enter a number. And what I want to do now is I want to be able to get the number that they enter. So I'm just going to say console.readLine. And this is going to go ahead and wait. It's going to pause the program until they enter in a line of text. And so what I actually want to do is I want to store the number that they enter inside of a variable. So I'm going to create a variable over here, int, and we're just going to call it num1, and I'm going to set it equal to console.readLine. But you'll notice over here we're getting an error. And the problem is that console.readLine is going to give us a string. So console.readLine takes whatever the user enters and turns it into a string, and that's sort of the value that we have. If we want to eventually add these numbers together, we're not going to be able to use a string like I showed you before. So we're actually going to have to convert this into an integer, which now we know how to do. So I can just say convert.toInt32, and I'm going to surround console.readLine, this whole thing, with parentheses. So now this whole thing is surrounded with these parentheses, and it's going to get converted into an integer. And that's basically all we need to do for that. So now I'm going to copy this, and we'll be able to get the second number. So I'm going to come down here, and I'll just say enter another number, and we're going to call this one num2. So now we're prompting the user for a number, we're getting that number and turning it into an integer, and we're doing the same thing down here. So the last thing we want to do now is just print out the answer. So I'm going to go ahead and say console.println or writeLine, and I'm just going to write out num1 plus num2. Because we converted these guys into integers, we're going to be able to add them together. So let's go ahead and run this program, and we'll see how we did. It says enter a number, so let's enter in a 10, and enter another number, so why don't we enter in a 3? And so now it's going to convert both of those into integers and add them together, and we get 13. So it looks like the program's working out pretty well. There's actually a problem with this program though. If I was trying to add a integer number with a decimal number, so if I said like 4, and over here I put in like a 2.6, this is actually not going to work. So you'll see the program isn't actually printing anything out. That's because the program is stalling. We didn't enter in a correct value. We entered in a decimal value, and this can't be converted into an integer. So you'll notice that the program over here is stalling. And basically that's because we entered in a decimal number. So if I wanted to allow this program to be able to handle decimal numbers, instead of converting these to integers, I'd want to convert them to doubles. So I could change both of these to doubles like this, double, double. And instead of saying convert.to in 32, I could say convert.to double. And same thing down here. And now we should be able to work with decimal numbers in our program. So let's see if we can do that. I want to add 2 and 3.6. And now we're able to add those two together. So in certain circumstances, you might want to have a situation where the user can only enter in integer numbers. But I think in most cases, you'd want to use doubles just like I did down there. And you can see how easy it is to convert them into doubles instead of integers. So that's a very basic calculator. And that kind of gives you an idea of how we can get numbers as input from a user. In this tutorial, I'm going to show you guys how to build a little Mad Libs game in C#. Now, if you're not familiar with Mad Libs, it's basically a game where you can enter in a bunch of like random words. So maybe like a couple nouns, an adjective, an adverb, and you'll take all those random words and you'll kind of sprinkle them in throughout a story. And generally, because you're entering in random words, the story ends up being like pretty funny. So I actually have an example of a Mad Lib over here in my web browser. You'll see it's basically just a little story and you kind of sprinkle in different words. Like this one, it's asking for an adjective or a plural noun or a celebrity name. So these are pretty fun, and I actually want to show you guys how we can build a Mad Libs for ourselves in C#. It's actually really easy. And so down here, I have a little program set up. It's basically just writing out this story. So it's writing out roses are red, violets are blue, I love you. And this is sort of like a classic little poem, but I think this poem would be a lot better if we turned it into a Mad Libs. So how about instead of saying roses are red, we would say roses are, and we'll let the user choose a color. And instead of saying violets are blue, we'll let the user choose a plural noun. And instead of saying I love you, we'll let the user choose a celebrity that they're gonna love. And so we'll basically allow the user to enter in 3 random words, and then we'll sprinkle them in through our story, and hopefully it'll be pretty funny. So let's think about how we can build a Mad Libs. Essentially what we're gonna do is we're gonna have to prompt the user for input. We're gonna have to take that input and store it inside of variables. So let's go ahead and do that. And essentially what we're gonna need is we're gonna need 3 variables to store the color, the plural noun, and the celebrity. So I'm actually going to show you guys one way that we can do that, and we're actually going to declare these variables first, and then we're going to give them values. So up here, I'm just going to say string, and I'm basically just going to tell C# that I'm going to want to use 3 variables in my program. So I'm going to want to use one called color, I'm going to want to use one called plural noun, and I'm going to want to use one called celebrity. And I'm just going to put a semicolon after this. And if you've been following along with this course, we haven't necessarily been doing, exactly this every time we were creating variables. But this is one way that we can create a variable. And we're basically just declaring the variables up here. And now down here, we're going to go ahead and give them values. And actually, we want to let the user give these variables their values because the user is going to be entering in the color, the plural noun, and the celebrity. So let's go ahead and write out some prompts. So I'm just going to say console.write, and in here I'm going to ask the user to enter a color. So I'm just going to say enter a color. And after I prompt them, I want to wait for them to enter in the color. So I'm just going to say console.readline, and this is basically going to pause the program and wait for them to enter in a line of text. But I want to take the line of text that they enter and store it somewhere. So I'm going to store it inside of this color variable. So I'm just going to say color, which we declared up here. And down here, I'm going to give it a value. So I'm going to say color is equal to whatever the user enters. And we can basically do the same thing for the other 2. So I'm going to go ahead and copy this. And down here, I'm just going to paste it. So I'm actually going to make some new lines. And so now, instead of a color, we're going to want to get a plural noun. And then down here, instead of setting the color variable equal to whatever they enter, now we're going to store this value inside of the plural noun variable. And then finally down here, instead of asking for the color, we're going to ask for a celebrity, and we're going to store that inside of the celebrity variable. So now we've prompted the user to enter in those three things. We've stored all of their responses inside of variables. So the last step is to put those guys into our story. So over here, I'm going to say roses are, and I'm going to use the color. And then instead of just saying plural noun, I'm going to say plural noun plus are blue. And then finally, we'll do the same for the celebrity. So I'm taking the variables and I'm sprinkling them in through this story. So depending on what the user enters, this story is actually going to be a little bit different. So let's go ahead and we'll run this program and we'll see how we did. So over here it says enter a color. So why don't we enter in like magenta, enter a plural noun. Let's do microwaves, and enter a celebrity. Why don't we do like Tom Hanks? So all of these values that I entered are getting stored in the corresponding variables. And now when I click enter here, it should print all of them out inside of our Mad Libs. So I clicked enter and it says roses are magenta, microwaves are blue, I love Tom Hanks. So we actually built a fully functioning Mad Libs, right? I can go in, I can enter in any values that I would want, and those are going to get sprinkled into the Mad Lib. Now, over here, we built a very simple Mad Libs, right? This was, essentially 3 inputs, and then we put them into a very simple poem. But you can see how you could use this same technique in order to ask the user to enter in like maybe 10 or 20 different words, and you can make a way more complex story down there. So essentially with very few lines of code, I mean, this is probably, 10 lines of code, we were able to write out an entire Mad Lib in C#. In this tutorial, I'm going to talk to you guys about arrays in C#. A lot of times when we're writing programs in C#, we're going to be dealing with all types of data. And a lot of times we're going to be dealing with large amounts of data. And one way that we can manage and keep track of the data in our programs is by using variables. But the one problem with variables is that they can only store a single value. So I can create a variable like an integer variable or a string variable, but I could only store one integer or one string inside of that variable container. And a lot of times if we're dealing with huge amounts of information, we're not going to want to have to create like hundreds or thousands of variables. So there's actually another container, another type of data structure that we can use in C#, which is called an array. And an array is basically a structure that allows us to hold multiple pieces of information in the same container. So unlike a variable that can only hold one value, an array can hold multiple values. So you could hold 10 or 100 or 1,000 or even 1,000,000 values inside of an array. So a good way to think of an array is just a collection of individual variables, right? So an array can hold like 20 different values that you would normally have to put inside of a variable. So I'm going to show you guys how we can create arrays. We'll talk about sort of the basics of using them, and I'll kind of get you guys up to speed with using arrays in C#. So down here in my program, I'm going to go ahead and create an array. And remember, an array is just a container that can hold a bunch of pieces of information. So we create an array very similar to how we create a variable. The first thing we have to do is specify the type of information or the type of data that the array is going to hold. So we can use all the basic data types, string, int, double, boolean. We can use all those things. In our case, let's make an array of integers. So I'm just going to say int, and then I'm going to type a space. Now, whenever we're creating an array in C#, we always need to let C# know that. So the way that we can tell C# that we want to make a variable instead of an array is by making an open and closed square bracket. And that's going to signify that this is going to be an array. And then over here, I can type the name of the array that I want to create. So I can give this array a name. So why don't we just call this like lucky numbers? We'll create an array that's going to store a list of lucky numbers. In order to give this array some information, there's actually a couple different ways we can assign values to arrays. I'm going to show you guys all the ways in this tutorial. But the most basic way is to just make an open and closed curly bracket. And then inside of here, we can start typing out the values that we want to put inside of our array. So I can just start typing out some numbers and we'll be able to store them all in the same container. So over here, I'm just going to type like 4, 8, 15, 16, 23, 42. So I'm just typing out a bunch of different integers. And you'll notice that I have one value here, and then I separate it with a comma, and then I can put another value. So all of these would be considered elements inside of the array. So I would say like 4 is the first element in the array, 8 is the second element in the array. And we can delineate the elements using these commas. And essentially now we have a container, we have this lucky numbers container, which is able to store all of these values. And this makes it really easy for us to manage and maintain large amounts of information. So, I mean, over here I only have like maybe 6 numbers, but if I wanted, I could put hundreds or thousands or even millions of values inside of one of these arrays, and they're extremely useful. So now that we looked at how we can create an array, let's talk about how we can access the individual elements inside of an array. Right, because this array is going to be no use to us unless we can actually get access to each of these values. So I'm going to show you guys how we can do that, and I'm just going to do a console.writeLine. So we'll just print out a particular value onto the screen. So if I want to access a particular value, I can just type out the name of the array, so in our case lucky numbers, and then I want to make an open and closed square bracket. And inside of this square bracket, I want to give a number. So I'm basically going to specify the index of the element that I want to print out, or the index of the element that I want to access. So let's say I wanted to access this element 4 right here. It's the first element in the array. I'm going to put a 0 here. So this 4 element is at the 0th position. It's at the 0 index inside of the array. So now when I run my program, you'll see we're printing out 4. So we're printing out that first element in the array. And so the way that we index these array elements is starting with 0. So if you've been following along with this course, you'll know that this is the same way we index strings. So I would say that 4 is at index position 0 in the array, 8 is at index position 1, 15 is at index position 2, 16 at 3, etc. So we start counting. In other words, we start the indexing at 0. So over here, I could say like lucky numbers 2, and now we're going to get 0, 1, 2. We're going to get this 15 back. So we'll be printing out that 15. You can see over there. So essentially, when we access an element in the array like this, it's a lot like we're accessing a variable. And it's actually, you can think of each one of these elements in here as their own kind of separate variables. And you can do everything with them that you could do with normal variables. So another thing we could do would be to update one of these elements. So for example, if I wanted, I could go ahead and change one of the values over here. So let's say we wanted to change this element. We wanted to change 8. Well, I could actually just say lucky numbers, and I'll make an open and close square bracket. I'm going to put the index of the element that I want to change. So this 8 is going to be at index position 1, and I can give this a new value. So we could give this a value of like 900. Now, if I print out lucky numbers 1, you'll see that the value will have updated. So now we get the value of 900 instead of just getting the value of 8. So I'm able to update these. I can really, do anything that I could do with a normal variable with each one of these individual values, and that's pretty cool. So in addition to creating an array of integers, I could also create like an array of strings. So why don't we do that? I'm going to make an array of strings, and I'm just going to call this friends. So this will be like a list of maybe my friends or something. And I'm going to show you guys another way that we can create an array like this. So you'll see up here right away, I was giving this array a bunch of values. So right off the bat, when I created it, I was populating this array with a bunch of information. But a lot of times when you create arrays in C#, you're not going to know exactly what elements you want to put inside of them. So if you don't know exactly what elements need to go in here up front, we can just create an empty array. So I could actually just say string friends, and I'm just going to set this equal to new string, and then I'm going to type an open and close square bracket. And inside of these square brackets, I need to put a number. And this number is going to tell C# how many elements we want this array to be able to hold. So if we create an array like this and we don't give it elements like we did up here, we still need to tell C# how many elements this array can hold. We need to basically tell C# how big we want to make the array. So over here, if I put 10 like that, that means that this friends array is going to be able to hold 10 values. If I put 3, that means the friends array is going to be able to hold 3 values. So why don't we put 5? And down here, what I can do is I can populate this array with information. So I could say like friends 0 is equal to, and then I could type out the name of a friend. So I could say like Jim. And then I could do the same thing for the other one. So I could say like friends 1 is equal to Kelly, etc. So I could do that for each element inside of this array and individually populate it. And this is actually going to come in handy in a lot of situations. And as we go forward in the course, I'm going to show you guys how we could do something like that in a future tutorial. But for now, just know that this is another way that we can create an array. All right, so really that is the basics of using arrays. Arrays are extremely simple, but they're extremely powerful. It's essentially just a type of container, much like a variable, but unlike a variable, it can store multiple pieces of information. And again, all of those pieces of information need to be of the same type, just like we have up here. In this tutorial, I'm going to talk to you guys about methods in C#. Now, a method is basically just a little block of code where we can perform a specific task. So a lot of times when you're writing programs in C#, you'll have like a few lines of code, maybe like 5 or 10 lines, which are performing a specific task. Like the whole idea of having those lines in the program is that they're going to do a certain thing. So what we can actually do is we can create something called a method, which will allow us to take all that code and put it into its own little container. And then when we want to execute it and we want to perform the task that that code is going to carry out, we can just call that method and we'll be able to reuse it in different spots in our program. So I'm going to show you guys exactly how to create a method, and we're going to talk exactly about what it does and how they're useful. So what I want to do in this tutorial is I want to create a method which is going to say hi to the user. So the task of this method is going to be to say hi to whoever is using the program. So what I want to do when I create a new method is I actually want to come down out here outside of these curly brackets. So believe it or not, this line of code up here where it says static void main, this is actually a method inside of our program. So like I said, a method is just a container, or it's sort of like a block where we can put code that's going to perform a specific task. And this main method is very special because this is the method that gets executed when we run our program. So any code that I type down here in this main method gets executed when I run my program. But in addition to writing this main method, we can also define other methods that are going to work a little bit differently, but it's the same idea. We're encapsulating a bunch of code inside of its own little container. So in order to create a new method, I want to first go outside of this main method. So this main method is all the code that I have highlighted. You can see it's delineated with this open and closed curly bracket. So I'm going to come down here below this, and we can actually create a new method. So when I create my method, I need to tell C# a couple different things. And the first thing we need to do is say a keyword static. And I'm actually going to talk a lot more about what static means in later tutorials. And as of right now, it's really not super important as to what this is doing. Again, I will explain what this is, but for now, just know that we have to put static here if we're going to put our method alongside this main method. After I say static, I need to specify something called a return type. Now, these methods are awesome because they can perform specific tasks for us. And one of the things they can do is they can actually give us back information. So if I was to run one of these methods, it can actually give information back to me. And you'll see how to do that. We're going to talk more about return types in the next tutorial. But for now, I'm just going to say void. And that basically means that this method isn't going to return any information. So this is kind of like the simplest method that we can create. All right, so after I say void, I want to give this method a name. Now remember, methods are generally going to be performing a specific task. So you want to name the method based off of the task that it's performing. Our method in this tutorial is basically just going to say hi to the user. So I'm just going to call this say hi. And generally in C#, when we're creating a method, we're going to create it using a capital letter for the name. So you can see I named it just like that. You can also see up here, main was named with a capital letter. And that's just a naming convention. That's not necessary, but a lot of people are going to do that. Then what we want to put in here is an open and closed parentheses, and then an open and closed curly bracket over there. And I'm just going to go ahead and indent into this curly bracket. Any code that we put inside of these two curly brackets is going to be considered part of the method. So any code that we put in here will be run when we call our method. So I can essentially write all the code in here to perform the task that the method is designed to carry out. Remember, this method is just going to say hi to the user, so I can basically just print something out onto the screen. I'll say console.writeLine, and why don't we just come over here and say hello user. Our method down here has one line of code, and methods can have as many lines of code as you want. I mean, you could have, I'd say most methods have anywhere from 5 to 10 lines of code, but you can have more or less than that. It doesn't really matter. In my case, though, I just have a very simple method, so it's going to be one line of code. All right, so now what I want to do is go ahead and run my program, and we'll see what happens. So I'm just going to click this start button, and you'll see over here, nothing got printed out. So even though we created our new method and we put a line of code inside this method, it didn't execute this line of code. In other words, this line of code never got executed by C#. Here's the reason. When we create a method, this code isn't going to get run automatically. Only the code that's inside of this main method is going to get run when we run our program. So because this code wasn't inside of this main method, it didn't get run. Now, if I want to execute all of the code inside of this say hi function, I can actually do something called calling it. So I can call this method. Basically what that means is C# is going to go over to the method, execute all of the code inside of it. So the way I can call the method is just by typing out its name. I can just say hi, and I can make an open and close parentheses. And then now we should be able to execute this code. So when I run my program now, you'll see we're printing out hello user. So the code inside the method got executed. Now, essentially what's happening is whenever C# sees this line of code, what it does is it jumps over, it goes over to this say hi method, and it's going to go through and execute all of the code inside of there. Then when it's done executing the code inside of here, it's going to come back and it's going to move on to the next line of code in the main method. That's essentially what's happening. So this is extremely useful, and there's going to be a lot of circumstances where you're going to want to have methods that are doing different things, and you're going to want to have all of that code inside of its own single container. But this is really just scratching the surface of what we can do with these methods. And I want to show you guys another thing we can do. We can actually give these methods information. Inside of this say hi function, I could actually specify that this say hi function should take in some information. And this is what we would call parameters or arguments. And a parameter is basically just a value that gets passed into a method. So it's a value that we would give to this method, and then it could use that value to perform its task better or do something. And the way that we can specify a parameter is just by coming in here into the open and close parentheses, and I can just basically specify what type of information I want to accept. So let's say that instead of saying hello user, we wanted this method to say hi to a particular person. Well, over here I could specify string name. And now when I write out this line string name, I'm basically saying that the say hi method needs to take as a parameter, as an argument, one value, which is going to be a name. Then what I can do is I can come down here and I can print out hello name. You'll see we're getting an error up here when we're calling this method. That's because I didn't include a name when I called it. So now whenever I call this method, I have to pass it a string. So I'm going to pass it the string Mike. And essentially what's going to happen is this string Mike that I passed this method is going to get stored inside of this string variable, inside of this name variable, and then I'm just going to print it out. So now we should be printing out hello Mike. And you can see we get that right there. So that's one cool way that we can run these methods. And the other cool thing about methods is that I can call this code as many times as I wanted. So I could call it again and again, and each time pass in a different name. So we'll pass in Mike, John, and Tom. And now each time we call this, the method is going to do something slightly different. So it's going to say hi to someone different. So now it's saying, whoops. Now it's saying hello Mike, hello John, hello Tom. So really what we're doing is we're able to write this code in one place, and then we're able to reuse it continually inside of our program. And that's another reason why methods are awesome. In addition to just passing in one parameter, we could also specify that this should take 2 parameters. So instead of just a name, why don't we also pass in an integer age? And then down here, we can add the age in. So I can say, hello name, you are, and then we'll just print out the age. So now when I call these methods up here, you'll see we're getting more errors because I have to give these values. So I can say like 33, 56, and 12. And now when I run my program, it's going to be able to handle that. So this method is now printing out both the name and the age that we passed in. And really, you can pass anything you want into these methods. You can pass strings, ints, doubles. You can even pass things like arrays. It doesn't really matter. You know, any value that you want to work with, you can pass into here, as long as you can specify it over there. So that's kind of the basics of working with methods. Now, I will say, you'll hear most of the time people are going to call these methods. You'll also hear people refer to these as functions. Methods and functions are essentially the same thing. There is a small difference just in the definition, but generally you can use the word method and the word function interchangeably. And you'll hear a lot of people call these functions. You'll also hear a lot of people call them methods. But generally in C#, like the official term would be a method. So that's really why methods are useful. You can kind of see, you know, we were essentially able to reuse all of the code that we wrote down here. So I can reuse it and give it different information and it'll do different things. Now, in the next video, I'm going to talk to you guys about this value over here, which is going to be the return value. So in addition to passing information into methods, methods can also pass information back to the callers. And we're going to talk about that in the next tutorial. In this tutorial, I'm going to show you guys how to use return statements in C# methods. So in C#, a method is basically just a little block of code which is designed to perform a specific task. And in the last tutorial, I showed you guys how we could create a very simple method that would say hi to the user. In this tutorial, I want to show you guys how we can use another feature of C# methods, which is the return keyword. And basically what we can do is inside of these methods, we can return values back to the callers. So I'm going to show you guys how this works and we'll kind of get an idea of what this is and what it does. So down here in my program, you'll notice I have my main method over here. And I'm actually going to create another method. So I'm going to come down here below the main method. And I want to create a method which is going to cube a number. So when you cube a number, you basically take it to the third power. So 2 raised to the third power is the same as 2 times 2 times 2, right? So we would say that this is 2 cubed. So what I want to do is actually create a method that will take as a parameter, so take as an argument one number, and then it'll cube it. And it'll actually return that number back to the caller. So this is going to be kind of cool. So remember, whenever we're creating a method, we need to say static. And like I said, I'm going to explain what static is and what it does later in the tutorial. But for now, just know that whenever you're creating a method here next to this main method, because main is such a special method, I'm also going to use this static keyword for the new method that I create. Then the next thing I need to tell C# is going to be the return type. And in the last tutorial, we used this void return type, which basically meant we weren't going to return any information. But now what I want to do is I want to actually specify a particular data type that we're going to return. So in our case, why don't we just say we're going to return an integer. So now what I want to do is give this method a name. So I'm just going to say cube. So it's going to be called cube because it's cubing a number. I'm going to make an open and close parentheses and an open and close curly bracket. Inside of this parentheses, what I want to do is specify a parameter. So this cube method is going to take one parameter and it's going to be an integer and we're just going to call it num. So num is going to be the number that they pass in, and eventually what we're going to want to do is we're going to want to return to them the value of num cubed. So what I can do down here is I can make an integer, and I'm just going to say int, and we'll call it result. And I want to set result equal to the cubed value of num. In order to get that, we can just say num times num times num. And so now this variable result is going to have num times num times num stored in it. In other words, it's going to have the num cubed stored inside of it. Now, what I want to do is use a special keyword in C# called return. And whenever we put this keyword inside of a method, this is basically going to tell the method that we want to return a piece of information back to the caller. And also this return keyword is going to break us out of the method. So over here, what I can do is I can just say return result. So I'm going to go ahead and return this result variable that we just created back to the caller. Now let's go up here in our main method and actually call this method. So what I want to do is I'm just going to call it. So I'm going to say cube and I'll pass in a number. Let's pass in 5. So now I'm going to go ahead and run my program and we'll see what happens. So you'll see my program ran, but I mean, nothing really happened, right? There was no output. There really, there was no errors, but really nothing happened. Here's the thing though, if I was to come over here and say console.writeLine, if I printed out this method, in other words, if I printed out calling this method, you'll see we're actually going to print out result. We're actually going to print out the value of cubing these numbers. So over here, I just said console.writeLine, and inside of here, I'm printing out cube 5. Now when I run my program, you'll see we're printing out 125. Basically what happened was when I used this return keyword down here, that returned the value back over to this method. So then when I called the method, it was actually given the value of 125. And that is extremely useful. And that's basically a way that we can get a piece of information back from a method. Just to further illustrate this point, I want to create another example. So down here, I'm going to make an integer, and I'm just going to call it cubed number, and I'm going to set it equal to cube 5. So I'm actually setting this variable equal to cube 5. Now I could print out cubed number, and you'll see we're going to get that value 125 back. And so that's essentially what we're able to do. We're able to return a value back from this method. In addition to returning an integer, we could return anything. So if I wanted, I could return a string or a double, or I could even return like an array of doubles, right? Something like that. So you can really return any value that you want back from these methods. But returning information can be extremely useful, and you're definitely going to want to use it inside of your C# methods. In this tutorial, I'm going to talk to you guys about if statements in C#. Now, an if statement is basically a special structure in our program which will allow our program to respond to different situations. So essentially with if statements, our programs can become smarter. And I want to show you guys some examples of if statements, and we're going to kind of look at how we can create and use if statements in our programs. Now over here I have this little text file open, and one of the cool things about if statements is that as human beings we encounter them every single day. So over here I have some examples of if statements that you might see on a daily basis. So up here it says, I wake up, if I'm hungry, I eat breakfast. So this is an example of an if statement. Essentially an if statement has two parts. It has a condition, which is right here, and then it has an action that gets executed when the condition is true. So our condition up here is if I'm hungry. Now this condition is either true or false. It can only have two possible values, true or false. You're either hungry or you're not. If you are hungry, in other words, if this condition is true up here, then you're going to eat breakfast. But if you're not, if this condition's false, then you're just going to move on. And that is the essence of an if statement. We check a condition. If the condition's true, then we'll perform an action. If the condition is false, then we'll move on and we won't perform that action. So just like you're able to make a decision about whether or not you're hungry and whether or not you should eat breakfast, we can use these in our programs to do the same thing, to make decisions. There's another one down here. It says, I look at my phone. If it's about to die, I charge it. So again, this is a condition. It's either true or false. If it's true, if your phone is about to die, then you charge it. Otherwise, we're just going to move on. Here's a little bit of a more complex if statement. It says, I leave my house. If it's cloudy, I bring an umbrella. So again, here's our condition. If it's true, then we're going to bring the umbrella. If it's false, though, now we're going to do something else. So up here, when the condition was false, we just moved on. But now, if this condition's false, otherwise, we're going to bring our sunglasses. So we're going to do something else. And these are just some basic if statements, but I just kind of wanted to give you guys an idea of what these were before we implement them in our programs. So we can do essentially this same thing, but we can allow our programs to make decisions. So when certain conditions are true, we can do certain things. And if they're false, then we can do other things. So let's go back over to our program.c#, and you'll see down here I'm just in my main method. And I'm going to show you guys how we can use some if statements. So before we do any if statements, I'm actually going to create a variable. So this is going to be a Boolean variable, and I'm just going to call it isMale. And this variable is going to tell us whether or not somebody is a male. So I'm a male, so I'm going to set this equal to true. So now we have this Boolean variable isMale, and it has a value of true. Now what I want to do is I want to create an if statement, and we can actually create an if statement based off of this isMale variable. So let's say that we have this variable in our program, we're working with it, and we want to do something when the person is male. So inside of our program, when the person's male, when this variable is true, we want to be able to do something. I can use an if statement to check that. I can come down here and say if, and I'm going to make an open and closed parentheses and an open and closed curly bracket. And this is sort of the general outline of an if statement in our program. Now, inside of this parentheses, I want to specify a condition. So just like over in that text file, we had some conditions like if I'm hungry or if my phone's about to die. Inside of these parentheses, we want to specify a condition. Now, this condition needs to be a true or a false value, right? If I'm hungry, that was our condition before. That's true or false, right? It can only have one of two values. If my phone's about to die is true or false. It can only have one of two values. So inside of this parentheses, we need to put a condition, which is basically just going to be a true or a false value. So in my case, I want to check to see if the person is male. So I can say if is male, and if this variable is true, then we're going to be able to execute the code that we put down here. So why don't we just write out console.writeLine, and we'll just write out you are male. So we're writing out console.writeLine if the variable is male is equal to true. So let's go ahead and run this program, and you'll see over here it's printing out you are male. So our program was smart enough to determine whether or not someone was male. If I was to set this equal to false, and now I went to run my program, when I run the program, you'll notice that nothing is going to get printed out because the variable was false. So this line of code down here only gets executed when this condition up here in these parentheses is true. So that's how we can use a basic if statement. But let's say that when isMale was false, we wanted to do something else. So let's say even if this variable was false, we wanted to try and do something else. Well, I can actually use another keyword in C#, which is called else. So I can say else, an open and closed curly bracket, and then down here we can write out another line of code. So I'm actually just going to copy this guy, and down here we're going to write out you are not male. So when they are male, we'll tell them that, and when they're not male, when isMale is false, we'll also tell them that. So isMale is false right now, and it should tell us that. So it should tell us you are not male. Essentially what we've done now is we've created a program that is able to respond to the value of a variable. So this program can respond to this variable, right? If isMale is true, then we're going to print out you are male. If isMale is false, then we're going to print out you are not male. So our program is smart. Our program can adapt and adjust what it's doing depending on the value of a variable. And therein lies the essence of if statements. If statements allow our programs to make decisions and to do different things when different conditions are met. But this is a very simple if statement. In fact, this is probably like the simplest if-else statement that we could write. I'm going to make this a little bit more complex, and we're going to go ahead and we're going to create another variable. So I'm going to come up here and make another Boolean, and I'm just going to call it isTall. And this isTall variable, again, is going to store a true or a false value. So why don't we set both of these equal to true just to start off. So this isTall variable is going to tell us whether or not someone is tall. So this will determine if they're like tall or short. And down here, let's say that instead of just checking to see if they are male, we also wanted to check to see if they're tall. So I can say if is male, and I can actually use another operator in C#, and it's called the AND operator. So I can say two ampersands like this, and this stands for AND. And basically, when we use this AND operator, it allows me to write two conditions in the same condition block. So it allows me to not only check to see if they're male, but I could also check to see if they're tall. So now this is saying if is male and is tall. So now, not only does is male have to be true, but is tall also has to be true for this whole thing to be true. So if one of these guys was false, then this whole thing would be false. So now down here, I could say you are a tall male, right? And then down here, instead of saying you are not male, I could instead say you are either not male or not tall or both, right? Because if this code gets executed, it means one or both of the conditions up here is false. So let me demonstrate this. You'll see over here, both of these are set to true. And when I run my program, it's going to be able to respond to that. So you'll see it says you are a tall male because both of those were true. But let's say I set one of these to false. So I set is male equal to false. Well, now, because one of these guys is false, this whole thing is going to be false. So we're going to print this out down here. So now when I run the program, you'll see it's printing out you are either not male or not tall or both. So it's able to respond to those two variables in our program. In addition to using this AND operator, we can also use another operator which is called OR. And OR does the same thing as AND, except it's a little bit different. So OR will allow us to check two conditions, but this time only one of these conditions has to be true for this whole thing to be true. So we would read this as if is male or is tall. So they either have to be male or they have to be tall, or they can be both, and then we'll be able to execute this code right here. But if both of these guys are false, then we're going to go down here and execute this code. So let me just demonstrate this really quick, and I'm not going to bother changing the text here. You guys kind of hopefully get what's going on. So even though false and true are both up here, so even though one of these guys is false, we're still going to be able to print out you are a tall male. But if I was to make both of these false, now we're going to end up printing out you are either not male or not tall or both. Which again, I realize isn't the right text for that, but you can just kind of understand what's going on. So it says you are either not male or not tall or both. So that's the difference between and or. When we use and here, both of these conditions have to be true. So both of these variables would have to be true for this whole thing to be true and for us to execute that code. When we use or, only one of them has to be true. So this could be false or this could be false, but one of them has to be true for the whole thing to be true. And that's really the difference. So I'm going to turn this back to and I want to show you guys some other stuff we can do. So right now we're able to check the condition where they're male and they're tall. But there's also a couple different scenarios in addition to that. For example, let's say that they're male, but they're not tall. Well, what if we wanted to do something when they were male, but they were not tall? So if they're like a short male. I can actually use another keyword, or another reserved word in C#, which is called else if. And I can just type out else if like this. I can make an open and close parentheses and an open and close curly bracket. And then I'm just going to make a new line. So essentially what I did here was I added in else if, and then you can see this else basically goes after it. When I use else if, it allows me to check another condition. So if this condition up here is false, I can actually come down here and check another condition. So we wanted to check to see if they were male and they were not tall. So I could say else if is male, and now I need to figure out how I can specify not tall. So remember, this variable is tall will tell us if they're tall or not. If I wanted to find out if they're not tall, I could just say exclamation point is tall. And this is going to read as not tall. Not is tall. This exclamation point here is what's known as the negation operator. And this will basically negate the condition. So over here I have is tall. If this was true, then when I put this exclamation point here, it's going to make it false. If this was false, when I put this exclamation point here, it's going to make it true. So this whole thing is going to be true when the person is not tall. And so now this is essentially checking to see if they're male and they're not tall. So down here we could write another message. So I could basically say like you are a short male because they're male but they're not tall. And finally I'm going to make one more else if. So I'm just going to come down here and there's one more thing that we want to check. So I also want to check to see if they're tall but they're not male. Right? So over here we're checking if they're male and they're tall. Over here we're checking to see if they're male and they're not tall. Down here, I want to check to see if they're not male and they are tall. So this is saying else if not male and is tall. So down here we can put another little message, and I'm just going to basically say like, you are not a male, but you are tall. So this is essentially just saying exactly what it is. You're not male, but you are tall. And then down here for this else, remember this code now is only going to get executed when none of these conditions up here are true. So now down here we can just say you are not male and not tall. All right, so let me walk you guys through this one more time. Up here I'm saying if is male and is tall. So this condition is only going to be true when both of these are true. And then if this is true, we're going to come down here and execute this code. We're going to say you are a tall male. But if this is false, we're going to come down here to this else if, and we're going to check another condition. So only when this is false are we going to check this condition down here. And we're basically going to check to see if they're male and they're not tall. And I'm using this negation operator here. And if that's true, then we're going to tell them that. We're going to print that out. Then we're going to check to see if they're not male and they're tall, and we'll print out a message for that. And then finally, we'll say you are not male and not tall. So let's go ahead and run our program, and you'll see both of these guys are going to be set to true initially. And we'll try all these different combinations. So both of them are set to true. I'm going to run the program, and it says you are a tall male. So our program was smart enough to be able to respond to the value of these two variables. So now let's set is male equal to false. So I'm going to come down here and we'll just say false. And now essentially this is going to be able to respond. So I can run my program now, and you'll see it's printing out you are not male, but you are tall. So it was able to respond to that different value. Now we'll set is male back equal to true, and we'll set is tall equal to false. And now we should get a appropriate response. So it says you are a short male. And finally, if these are both equal to false, then again, the program's going to be able to respond to that. So it's going to say you are not male and not tall. Awesome. So essentially what we did with these if statements was we allowed our program to respond to different values, right? Our program was able to make decisions based off the information that it was given. And this is really just scratching the surface of if statements. You'll see over here we're using these Boolean variables, right? But there's actually another way that we can specify these conditions, and it's using something called comparisons. And in the next tutorial, I'm going to talk to you guys all about comparisons, about how to use them, and it's basically just another way that these if statements can come in handy. In this tutorial, I'm going to talk to you guys some more about if statements. More specifically, we're going to be talking about comparisons. So inside of an if statement, we can actually compare two values, and depending on the result of the comparison, we can do different things. This is going to be kind of cool. And essentially what I want to do in this tutorial is I want to build a method. And this method is basically going to be a max method. So the max method, if you're not familiar, is basically a method where we can give it two numbers and it'll tell us which one is bigger. So we're going to write a method that takes two parameters as input, num1 and num2, and then we'll basically be able to return whichever is bigger. So I'm going to go down here and I'm going to go below this main method, and we're going to create another method. So I'm just going to say static, and I'm going to want this to return an integer. So why don't we just say that it's going to return an integer, and I'm going to call it get max. And then I'm going to make an open and close parentheses and an open and close curly bracket. So get max is going to take one or two parameters. So we're going to take an integer num1, and then we're also going to take another integer num2. Basically, the job of this method is to figure out which of these two numbers is bigger and then return it to the caller. So let's go ahead and set this up. I'm actually going to create a variable. So I'm just going to make an integer. I'll call it result. And I'm not actually going to give this a value yet. So we're going to end up giving this a value inside of the method. And then down here, I'm going to return result. So I'm just going to return this variable. And inside of this method now, our goal is to figure out which number is bigger, right? So inside of this method, we don't know if num1 is bigger or num2 is bigger. We have no idea, right? All we know is that we have two numbers here that we can work with. So what we want to do is use an if statement, and an if statement will allow us to do something when a certain condition is true and do something else when a certain condition is false. So I'm going to make an if statement. I'm just going to say if, and I'm going to make an open and close parentheses and an open and close curly bracket. So this is like the sort of outline, the structure for our if statement. Now, inside of these parentheses, I need to put a condition. And remember, a condition is a true or a false value. In the previous tutorial, we were using Booleans as our conditions. So I had a Boolean like is male and another one is tall, and we use that as the conditions for our if statements. But here's the thing, we don't necessarily have any Booleans to work with, right? All we can work with here are these two integers. So what I can do is I can actually use something called a comparison. So I can compare the two numbers. So I could actually say like if num1 is greater than num2. And essentially what I'm doing here is I'm comparing the two values. But remember, inside of these parentheses, we need a condition. We need a true or a false value. But actually, the cool thing is that when we do this comparison, this is going to resolve down to a true or a false value. Right? So num1 is either going to be greater than num2 or it's not. There's only two possible scenarios with this comparison. Right? Either it's true and num1 is greater than num2, or it's false and num2 is greater than or equal to num1. Right? So really this gets resolved down to a true or a false value anyway. So these comparisons can be super useful inside of our parentheses. Now, inside of this actual if block, if num1 is indeed greater than num2, then we can just set result equal to num1. And then I'm going to make an else statement down here, and I'll just say else, and I'm just going to say result is equal to num2. So if num1 is greater than num2, then we'll make result num1. Otherwise, we'll make it num2. And then down here, we're just returning result. So this method is basically done. We have everything that we need. We should be able to figure out which number is bigger. So let's go back up here to our main method, and I'm going to call this. And I'm actually going to print out the answer. So I'm just going to say console.writeLine, and then inside of these parentheses, we're going to call it. So I'll just say get max. And why don't we pass this 2 and 10. So ideally, we're going to get a 10 back because 10 is the bigger number. So let's go ahead and run this program, and you'll see we're getting that 10 back, no problem. So let's now see if it's going to work when the first number is the bigger one, and hopefully it does, so we should get 20, which we do. So this method is working out, and you can see we were able to use this comparison in order to figure it out. So that's awesome, and this is pretty cool, but I'm going to get rid of this. Let's up the ante a little bit. Let's make this a little bit more difficult. Let's say instead of 2 numbers, we wanted to be able to compare 3 numbers. So we wanted this max function to be able to tell us the maximum of 3 separate numbers. Well, in here, I can just specify another parameter. So I can say num3. And now down here, not only do we have to figure out 2 of them, but we have to figure out 3 of them. So of these 3 numbers, which one is bigger? Now, we're going to want to use another if statement. So I'm going to go ahead and this time I'll make that same if statement essentially. And now we need a condition. So not only do we need to check to see if num1 is greater than num2, but we also have to check to see if it's greater than num3. So I'm going to say if num1 is greater than or equal to num2, and so I'm using this and operator, num1 is greater than or equal to num3, then down here we can set result equal to num1. Because if num1 is bigger than num2 and it's also bigger than num3, then we know it's the biggest one, right? So we can just go ahead and return that. But let's say that this isn't the case. I want to do another one, so I'm going to say else if, and we'll make another condition down here. So I'm basically just going to say else if num2 is greater than or equal to num1, and num2 is greater than or equal to num3. Right, so if num2 is bigger than num1 and it's bigger than num3, then num2 is the biggest. So we'll say result is equal to num2. Finally, then we can just say else, and down here we can specify the else. So I'm just going to go ahead and set result equal to num3. Because if num1's not the biggest, and remember we checked that up here, and num2's not the biggest, which we checked down here, then num3 is going to be the biggest. So let's go ahead and test this out. So now we need to include another number. So I'm going to put like a 4 in here. So we should get back this 20 because that's the biggest number. And you can see we do. Let's try it with the other places. So let's make this last one here. We'll make this a 40. So this is going to be the biggest. And we'll see if this works, which it does. So this getMax method seems to be working out pretty well. Now, down here, you'll notice when I compared the two numbers, I'm using these like greater than or equal to's, or before I just use a greater than. These are called comparison operators. And these comparison operators can be used to compare different values. So I can use greater than, less than, greater than or equal to, less than or equal to. I can also use equal to, and this double equals is special because it's going to allow us to compare these two numbers. So this isn't used for assignment. Like down here, we used a single equals for assignment. So I assigned the value of num1 to result. Up here, I'm comparing the value. So I'm basically checking to see if the value of num1 is equivalent or equal to the value of num2. And then we can also use one more, which is going to be not equals. And this is going to be the opposite. So this will say num1 not equal to num2. So that's essentially how we can use comparisons. And you can also, in addition to numbers, you could also compare like characters. So I could compare like two characters, basically like that. And that's going to work out just fine. So these comparisons are extremely useful. And I would say that a lot of times when you're using if statements, you're going to be using comparisons just like that. In this tutorial, I'm going to show you guys how to build a for-function calculator in C#. Now, if you've been following along with this course, you'll know that in the beginning of the course, we actually created a very simple calculator. And essentially, the calculator would let the user enter in two numbers, and then it would take those numbers and sort of add them together and then print out the answer, right? It's very simple. In this tutorial, we're going to take that calculator to the next level. So we're going to actually allow the user to enter in two numbers, and they're also going to be able to specify an operator. So they'll be able to specify whether or not they want to add the numbers, subtract the numbers, multiply, or divide the numbers. So it's going to be pretty cool. And let's go ahead and get into it. So the first thing we want to do is we want to be able to get all the information from the user. So I'm basically just going to be printing out prompts, and then we'll be storing the values that the user enters inside of variables. So the first thing I'll do is just print out a prompt, basically prompting them to enter in some information. And actually, I'm just going to use write instead of write line. So I'll say enter a number, and they'll enter their first number. And then what we want to do is we want to get that number and store it inside of a variable. So let's store this inside of a double. So I'm just going to call this num1, and I'm just going to set it equal to console.readLine. But remember, whenever we use console.readLine, this is going to give us a string back. So if I want to store this value inside of a double over here, I'm actually going to have to use something called convert. So I'm going to say convert dot to double, and I'm going to place console.readLine inside of this method's parentheses. So I'm going to pass this in as an argument, as a parameter to the convert.toDouble method. That's essentially what's happening there. And I'm basically just going to copy this line, and I'm going to paste it down here because we're going to do the same exact thing for the second number. So I'm going to say num2 is equal to convert toDouble console.readLine. So we're getting the first number and we're getting the second number, and we're storing them in the num1 variable and the num2 variable. Now, one more thing I want to do is I want to get the operator. So I'm basically just going to say console.write, and over here I'll just say operator. So this is going to be like a plus sign, a minus sign, division sign, multiplication sign, etc. And then down here, we can just make this a string. So I'm going to say string OP for operator is going to be equal to console.readLine. So basically what I'm doing is I'm getting the first number, I'm converting it to a double, I'm getting the operator, plus, minus, division, whatever, I'm getting the second number. So now, at this point in my program, I should have all the information that I need. So the question becomes, how can we perform the operation? In other words, we have the two numbers, great, but how can we figure out what the user entered in, right? How do we figure out what OP is telling us to do? We can use an if statement. So I'm going to use an if statement. I'm just going to say if I'm going to make an open and closed parentheses and open and closed curly bracket. And down here, we want to check a condition. So essentially what I want to do is I want to check to see if the operator is equal to a plus sign. So I can say if OP is equal to plus sign, right? If the operator is equal to a plus sign, then we know for a fact that they're trying to add the numbers. And I'm actually just going to print that out down here. So I can say console.write, and we're basically just print out num1 plus num2. And actually, I'm going to do write line here. All right, so if it's a plus sign, then we're going to be able to add the numbers. But what if it's not a plus sign? Well, I want to check another condition here. So I'm going to say else if, and we'll check another one. We basically want to check to see if the operator is equal to a minus sign. If the operator is equal to a minus sign, now we're going to do the same thing we did up here. It's just that we're going to subtract the numbers. So I'm going to say num1 minus num2. We can do the same thing for multiplication and division. So I'm going to go ahead and copy this code, and I'm just going to paste it down here. And down here, instead of checking minus, we're just going to check division. And then if it is division, we're going to divide the numbers. And then finally, I'm going to check for multiplication. So I'm going to say asterisk for multiplication, and then num1 times num2. So we're able to cover all four operations, right? Addition, subtraction, division, and multiplication. And each time, whatever the user enters, we're going to perform the correct operation, right? This if statement's pretty simple. But let's say that the user enters in an operator that's not equal to any of these guys up here, right? What if they enter in like a random character, like a string of text? Well, we want to be able to throw an error message. So what I can do is I can come down here and just say else. And then inside of this else block, I'm just going to say console.writeLine. And I'm just going to print out like invalid operator. So this will basically tell them like, hey, you had an invalid operator, like that's not good. So now we have our whole program, and we used our little if-else structure here to figure out what was stored inside of that OP variable. So we figured out what the user wanted us to do. Let's go ahead and run this program, and we'll see how we did. Over here it says enter a number. I'm going to enter 10 and enter an operator. Why don't we do addition and enter another number? Why don't we do like 5.5? So now when I hit enter, that if statement is going to execute, and it's going to see that plus sign, and it's going to be able to add the numbers. So you see here we get 15.5. So we successfully added the numbers together. Let's try a different one. I want to do multiplication. So let's do 60 times 4.23. And we get 253. Yeah, that seems about right. All right, so let's try one more, and we'll try to break it. So I'm basically just going to enter a number, 40. And now I'm going to enter in an invalid operator. So I'm going to enter in like an H for the operator, and then we'll enter in a 5. And now this should tell us invalid operator because the program didn't recognize that operator. In other words, it wasn't able to handle that. So we threw our little error message. And that's essentially all we need to do to build this for-function calculator. The magic is in the if statement. So we can use the if statement to figure out what calculation or what operation the user wanted to do. And we can just keep using all these different else ifs in order to figure that out. So this is extremely useful, and hopefully you can find a use for something like this in your programs. In this tutorial, I want to show you guys how to use switch statements in C#. Now, a switch statement is basically just a special type of if statement where we can check a bunch of different conditions really easily. And this will all be really clear in the example that I show you guys. So let's go ahead and get started. Down here in my program, I just have a very simple program set up. And in this tutorial, I want to create a method. So we're actually going to create a method which is going to convert numbers into days of the week. So if I pass this method as 0, it would give me back Sunday, because Sunday is the first day of the week. If I pass this a 1, it would give me back a Monday, right? If I pass this a 2, it would give me back Tuesday, etc., right? So if I, it's basically going to map numbers to the specific day of the week that we're going to give it. And this is going to be a pretty cool method. So I'm going to come down here, and we're going to go ahead and write the method. I'm just going to say static, and this is going to return a string. So it's going to return the name of the day of the week. and I'm just going to call this get day. And this method is going to take one parameter, and it's going to be the day num. So I'm just going to call this day num. So day num is going to be like 0, 1, 2, 3, 4, 5, 6, etc. Right? It's going to be a number, and we're going to take that number and we're going to convert it into a day of the week. Right? We're going to convert it into a string, which will be the day of the week. So I'm going to create a variable over here. It's going to be a string variable, and I'm just going to call it day name. And I'm not going to give it a value. And then down here, eventually, our goal is going to be to return day name. So inside of our little method over here, inside of our method block, our goal is to populate this day name variable with the value, right? With the correct value that's going to correspond to the day num that gets passed in. Cool. So I'm going to show you guys how we can use a special structure in C# to do this, and it's called a switch statement. So I'm going to set up my switch statement. I'm just going to say switch. I'm going to make an open and close parentheses and an open and close curly bracket. And down here, we're going to be able to start writing our switch statement. Now, the switch statement needs one piece of information inside of this parentheses, and it basically needs a value. So the whole point of the switch statement is we're going to pass it a value, and then we're going to check to see if that value is equal to a bunch of different stuff. And depending on what it's equal to, we're going to do different things. So this will be clear in a second. In here, I'm going to pass in day num. Because if day num is 0, I want to do something. If day num is 1, I want to do something else. If day num is 2, I want to do something else. In other words, my goal is to figure out what the day num is, and depending on what it is, I'm going to do something. In other words, I'm going to give this day name variable a different value. Now down here in the switch statement, we can make what are called cases. So I can come down here and I can just type out case. And over here, I can just type in a value. So I can say 0 here. And I'm going to make a colon. And down here, I'm basically just going to say day name is equal to Sunday. And I'm also going to say break down here. So let's talk about what this is saying. Essentially, this line, this little block of code is saying that in the case that day num is equal to 0, I want to do this. So in the case that day num has the value of 0, we're going to do whatever I specify down here. Essentially what I'm doing is I'm saying day name is going to be equal to Sunday. And I'm also saying break, and we're going to talk about break in 1 second. So now what I can do is I can create one of these cases for each of the possible numbers, right? So now instead of just making one for 0, I'll make one for 1. In the case that day num is 1, I'm going to say day name is going to be equal to Monday, right? And then again, I'm going to say break. And we'll do this one more time. I'm going to do it for 2. So in the case that day num is equal to 2, now I'm going to say day name is equal to Tuesday. And you'll notice here I'm using this break statement. And this is a special reserved word in C#, which basically says that we want to break out of the structure that we're currently in. So we're inside of this switch statement, and essentially what happens is with this switch statement, it's going to look through all of these different cases. So it's going to say, okay, is it 0, is it 1, is it 2? But let's say that day num is 0, right? So it says, is case 0? Yes. We're going to execute this. We're going to assign a value of Sunday to day num. If I don't put this break statement in here, then C# is going to keep checking all of these cases after that. So it's not going to stop. It's going to keep checking. So if you have a scenario where you want to be able to keep checking the other cases, even after one of them was true, then you can get rid of the break statement. But I think in most cases, you'll probably just want this break statement in there. All right, so I've made one of these for Sunday, Monday, and Tuesday. I'm going to go off and make some for the rest of the days of the week, and then we'll come back and check it out. All right, so I went ahead and made one of these for every day of the week. You can see we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And this is a really easy way to check all these different cases, right? I can just say case 6, day name, Saturday, etc. And so we basically have our case statement set up. We have our switch statement set up. But here's the problem. Let's say that the user passes a value into this method that's not 0 through 6. Right, so this switch statement can only handle values 0 through 6. But what happens if someone passed like a 100 into there? Well, I can actually account for that. So down here, I can create something called a default. I can basically just type out default. I can type a colon, And now down here, I can specify what I want to do if none of these cases are true. So I could come down here and I could basically just say day name, and we'll just set this equal to invalid number. Or why don't we say invalid day number. And this will basically act as like a error message. And then down here, we're also going to need to say break. So this is essentially how we can account for any values that aren't included up here as cases. So our function or our method seems to be done at this point. So let's go ahead and try it out. So remember, get day is going to take one value, which is going to be a num. And let's go up here to our main method and we'll try this out. So I'm actually just going to print out whatever we get. So I'm going to say console.writeLine, and I'm going to go ahead and print out get day. And let's pass this a 0. So I'm going to go ahead and say get day 0. So hopefully we should get Sunday back because Sunday is mapped to 0. And you'll see over here that we get Sunday back. So let's try another one. Why don't we try 4? And I think 4 is going to be Thursday. Yeah, so Thursday. And let's try one more. So I'm going to try an invalid number. So let's put 80 in here. So if I say get day 80, now we should get that error message, which tells us that it's an invalid day number. Yeah, so over here, we're getting that invalid day number. And so that's basically what we can do as switch statements. Now, let me just point this out. Everything that you can do with switch statements, you could actually do with if statements. The reason that we have switch statements though is because they make it a lot easier to do essentially what we're doing over here. You could do it with if statements, but it would be a lot messier than this and it would be a lot harder to manage. With switch statements, it's very clear, right? It's very clear what's going on and what values are getting mapped to what code. So switch statements are extremely useful and you should definitely consider using them in your C# programs. In this tutorial, I'm going to show you guys how to use while loops in C#. Now, while loop is basically a programming structure that allows us to loop over a specific block of code while a certain condition is true. And basically, using while loops, we're able to keep doing something repeatedly while a condition is true. And this can come in handy in a bunch of situations, and loops are extremely useful in a programming language like C#. So let's get started. I'm going to show you guys how they work and how to use them. Basically just to give you a general introduction into while loops. Down here in my main method, I'm actually going to create one thing, and this isn't going to be the while loop. I'm just going to create a variable. It's going to be an int, and I'm just going to call it index, and I'm going to set it equal to 1. And we're going to end up using this index variable inside of our loop. So now I want to create a while loop. So I'm just going to say while, and I'm going to make an open and close parentheses and an open and close curly bracket. Now here's how while loops work. Up here in these parentheses, I'm going to specify a condition. So if you're familiar with if statements, you'll know that with an if statement, we have a condition, right? We check a condition. And if that condition's true, then we execute the code inside of the if statement. Pretty simple. It's the same concept with this while loop. Up here in this while loop, I'm going to specify a condition. And if this condition's true, I'm going to be able to execute all of the code that goes down here in these curly brackets. The only thing is, with a while loop, not only are we going to execute it one time, but we're going to keep continuously executing it until the condition up here in these parentheses is false. So we're basically going to check this condition. If it's true, we'll execute all the code inside of these curly brackets, and then we'll check the condition again. If it's still true, we'll come down and execute it again. So you're continuously looping through this code. So it's essentially an if statement, but you keep going until the condition is false. And over here in these parentheses, we need to specify our condition. So I'm going to make a condition. I'm just going to say while index is less than or equal to 5. So as long as this index variable is less than or equal to 5, I'm going to keep executing all the code down here. And then down here, I'm basically just going to write a few lines of code. So I'm going to say console.writeLine, and we're going to print out the value of index. And then down here, I'm going to increment the value of index. So I'm going to say index plus plus. And remember, this plus plus basically just adds 1 onto the index. So essentially what's happening is every time we go through this loop, I'm going to print out the value of index, then I'm going to increment index, and then I'm going to go up back here and check the condition again. So this is our basic while loop. I'm going to run the while loop, we'll see what happens, and then I'm going to explain exactly what happens so we can get a better idea of how this works. Let's go ahead and run the program. And you'll see over here, I'm printing out 1 through 5. And maybe you expected that, maybe you didn't, but this is what we got. And I'm gonna go ahead and explain exactly how this happened step by step. So the first thing we did up here was we created this integer index and we set it equal to 1, right? Now, then we created our while loop. So when C# goes to execute our program, it's first gonna create this variable index and it's gonna store 1 inside of there. Then the next thing it's gonna do is check this condition. So the first thing, before it executes any of the code inside the loop, before it does anything else, it's gonna check this condition. So it's gonna check to see if index is less than or equal to 5. Since index was equal to 1 initially, that's gonna be true. So then C# is gonna go down, it's gonna execute this line, so it's gonna print out index onto the console, as you can see over here. Then it's gonna increment index. So index is now gonna be equal to 2. Then C# is gonna go all the way back up to this condition and check it again. So before C# is gonna execute that code a second time, it needs to check the condition again. So now index is equal to 2 and 2 is less than or equal to 5. So C# is gonna come down here, it's gonna print out 2 as you can see right there, and it's gonna increment index. Then it goes all the way back up and checks the condition again, right? So every single time we execute all that code, before it's gonna execute it again, it goes back up and checks the condition, all right? Eventually, we're gonna get to a point where index is gonna be equal to 5, and we printed out 5 over here. Then we're gonna increment it to 6. C# is gonna come up here, and it's gonna check, is 6 less than or equal to 5? And then the condition is gonna be false, so we're gonna break out of the while loop, just like that. And that's essentially how we can use these while loops. So it's very simple, right? You specify a condition, and you're gonna keep looping through the loop as long as that condition is true. Easy enough. Now, I do want to warn you guys of something. There is a possibility of something called an infinite loop. And an infinite loop is a situation where this condition up here never becomes false. So for example, if I was to get rid of this index plus plus, now this condition up here, index less than or equal to 5, this is always going to be true, right? Because we're never modifying the value of index. When we were incrementing it, eventually we would increment it enough to get to 5, but since we're not incrementing it anymore, we're just gonna loop infinitely. So let me show you guys what happens when I do this. When I run my program, you'll see over here that I'm just constantly printing out 1. I mean, it's literally just printing out 1 as fast as it can. And it's gonna do this forever if I let it. It'll do this infinitely because it's never told that it needs to stop. In other words, this condition up here is never false. And so that's why we have an infinite loop. And that's probably gonna happen to you as you play around with loops. Everyone's had an infinite loop before. And in most cases, you're gonna wanna avoid them, although there are some special cases where you're actually gonna want infinite loops. So that's sort of the basics of while loops. It's very simple, right? We have a condition up here. As long as that condition's true, we're gonna keep executing the code down here. And every single time we go through the loop, we check that condition again. I want to show you guys one more thing, and there's actually another type of loop that we can use, which is similar to a while loop. It's called a do while loop. And in order for me to kind of illustrate what this is doing, I want to show you guys an example. So if I came up here and set index equal to 6, let's talk about what's going to happen. So if index is equal to 6, right, the first thing that my program does with this while loop is it checks this condition. So the first thing, before it executes any of this code, before it's allowed to even touch that code, it checks this condition. So since index is equal to 6 and this condition is getting checked before we execute the code, this code is never gonna execute because 6 is not less than or equal to 5. This condition is false, so we're never gonna execute this code. So if I run my program, you guys will see that nothing gets printed out, right? We don't execute any of the code inside that while loop. But there's actually another type of loop, which is essentially the opposite of a while loop. And I'm gonna show you guys that. So I'm basically gonna take this while loop declaration up here. I'm gonna throw it down here, and I wanna make sure I put a semicolon after it. And then up here, instead of saying while, I'm gonna say do. And so now we have another type of loop, which is a do while loop. And the difference between a do while loop and a while loop is that a do while loop will execute the code inside of the loop before it checks the condition. So now, even though index is equal to 6, we're still gonna be able to execute this loop one time before we look at the condition, right? So it's basically gonna execute all of this code, then it's gonna look at the condition, it's gonna figure out that it's false, and it's going to go ahead and break out of this. So I'm going to show you guys how we can do this, and I'm just going to run my program, and you'll see that even though this condition was false, even though 6 is not less than or equal to 5, we were still able to print it out one time, because in a do while loop, you execute the code inside the loop first, and then you check the condition. So that's basically another type of loop that we can use. And do while loops definitely come in handy, and there's a lot of situations where you want to use them. Although I would say that by a huge majority, while loops are more useful. But do while loops are also awesome. So that's kind of the basics of while loops and do while loops. And this is really just the basics of looping in general. There's a lot of situations when we're programming where we're going to want to continually do the same thing until a certain condition is false. And that kind of gives you an overview of how it works. In this tutorial, I'm going to show you guys how to build a guessing game in C#. Now, this is going to be a very basic guessing game. Essentially, we're going to define a secret word, and then the user is going to have to try and guess that word. And we're going to keep asking the user to try and guess it until they get it right. So this is going to be kind of cool. And I'm going to show you guys how we can use some of the stuff that we've learned in this course so far, things like loops and if statements and variables. We're going to use all of them together to create this cool game. So let's start creating the game. Remember, this is going to be a guessing game. So the first thing we want to do is come up with a word that the user is going to have to guess. So I'm going to create a variable, and it's just going to be a string, and I'm just going to call it secret word. And the secret word, why don't we just give it a value? We'll set it equal to draft. So draft is going to be the secret word, and the user's goal for our game is going to be to try and guess that secret word. Now, I want to create one more variable, and we're actually going to call this one guess. So this is going to be another string, and I'm just going to say it's called guess, and why don't we just set it equal to this empty string over here. So I'm not really giving this a value yet. All right, so now we have our secret word, and we also have our guess. And what I want to do is I want to be able to keep prompting the user to guess the word until they get it correctly. So anytime in C# that we want to keep doing something repeatedly until a certain condition is false, we're going to use a while loop. So I'm going to go ahead and create a while loop, and I'm just going to make an open and close parentheses, open and close curly bracket. And there's really two things to this while loop. The first thing is going to be a condition, and the second thing is going to be the code that we want to continually execute. So let's think this through. What condition do we want to put up here? Well, basically, we want to keep looping while the guess is not equal to the secret word. In other words, as long as the guess that the user guesses isn't equal to what the secret word is, we want to keep looping and keep asking them to guess. So down here, what I want to do is keep prompting them to guess. So I'm basically just going to say console.write, and I'll write out to the screen a prompt. I'll say enter guess. And then now that we've prompted them to enter the guess, what I want to do is I want to take whatever they entered, store it inside of this guess variable, and that way we can keep checking it every time we go through this loop. So down here, I'm basically just going to say guess is equal to console.read line. So I'm going to go ahead and read the line of text that the user enters. Basically just read whatever word they entered in and store it inside of this guess variable. So essentially what's happening now is every time we go through the loop, we're prompting the user to guess the word, and we're storing whatever they guess inside of this guess variable. Then we're going to go up here and we're going to check to see if it's equal to the secret word. If it's not equal to the secret word, then we're going to go through and ask them again. But if it is equal to the secret word, then we're going to go ahead and break out of the loop. And then down here, we can just print out a success message. So I can just print out console.write, and I'll just print out you win. So this is our program. It's actually a pretty easy program. And I do just want to point out that in addition to using a while loop, we also could have used a do while loop in order to write this program. So if you want a little challenge and you want to try and challenge yourself, go ahead and try to write this with a do while loop instead of a while loop. And if you need to figure out what do while loops are, just check out the previous tutorial. I explained what they were. But for our case, I'm just doing it with a simple while loop just to keep it as straightforward as possible. But like I said, if you want a challenge, try it with a do while loop. So let's see if we can run our program. Believe it or not, this is actually all the code that we need for this guessing game. So I'm going to go ahead and run the program. Now you'll see over here it says enter guess. So I'm just going to type in some random text. And you'll notice that because this text didn't match the secret word draft, it's asking me to enter again. So I'm going to keep entering, and I could keep entering essentially infinitely many times, and it's going to keep prompting me to guess until I get the word. But if I was to type in the secret word, so if I was to type in draft here, now when I hit enter, draft is equal to the secret word. So we're going to break out of that while loop, and we're going to get this you win message. So that's essentially all our game did. It allowed us to keep guessing the word until we got it right. So this is a pretty cool game, and you guys can see down here, it's actually pretty easy for us to implement it. It was only maybe like 7 or 8 lines of code. But I think there's a little problem with this game, and the problem is that the user gets unlimited guesses, right? So the user can just keep guessing infinitely. I mean, technically they could type in, every possible combination of letters until they got the secret word right. And that's not a very good game. I think what would make this game better would be imposing a guess limit. So we could say like the user can only guess 3 times, or they can only guess 4 times. And if they don't get it in 4 guesses, then they lose the game. I think that would be a little bit better game. So why don't we try to implement that? Let's see if we can come up with some code that will allow us to program that game. Well, I think I know what we need to do. So the first thing we want to do is we need some way to keep track of how many times the user guesses, right? If we're going to impose a guess limit on this game, we need to be able to keep track of how many times they've guessed. So that was a good place to start. Why don't we just start with that? I'm going to create an integer, and I'm just going to call it guess count. And we'll set it equal to 0 initially, right? Because initially the user hasn't guessed at all. And what we want to do is we want to increment this variable every time the user guesses. So let's go down here, and you'll notice this is the code down here that allows the user to guess, right? It's this code which is essentially prompting the user to guess and then storing their guess. So in addition to prompting them and storing the guess, we can also increment the guess count. So I can come down here and I can say guess count plus plus, right? Just like that. So I'm incrementing the guess count every single time they guess. Awesome. But we're still going to need some more information. So another piece of information we're going to need is the guess limit. So we need to essentially tell our program how many times the user can guess. So I'm just going to make another int, and I'll just call this guess limit. And over here we can define how many times we want the user to be able to guess. Well, why don't we say 3 guesses? I think 3 guesses is enough. 3 strikes and you're out. And so now we're basically limiting the user to 3 guesses. I also want to create one more variable, and this is going to be a Boolean, and this is going to be called out of guesses. And I'm going to set this equal to false. And this Boolean is basically going to tell us whether or not the user is out of guesses. So if the user still has guesses left, this is going to be equal to false. But if the user is out of guesses, then this is going to be equal to true. So we're going to set it to false initially. And then down here, we need to use these 2 new variables inside of this while loop. So the first thing I think we should do is we should only allow the user to guess when they still have guesses left, right? In other words, I only want the user to be able to guess the word if they haven't already guessed 3 times, right? If they haven't guessed the guess limit. So what we can do is we can actually create an if statement. So I can say if, and down here I'm going to make open and close curly brackets. And inside of these parentheses, I need to put a condition. So let's think about this. What do we want to check? Well, I want to check to see if the user is out of guesses, right? So I can check to see if the guess count is less than the guess limit. And if this is true, in other words, if the guess count is less than the guess limit, then the user still has a guess left, so they can go ahead and guess. So I'm going to take all this code for guessing, and I'm going to put it inside of these curly brackets, right? So once again, we're checking this condition. If the guess count is less than the guess limit, then we're going to go ahead and print out all of this stuff. So we're going to allow them to guess the word, and then we'll increment the guess count. But if this isn't the case, in other words, if guess count isn't less than the guess limit, that means that they've already reached their guess limit, right? That means they don't have any guesses left. So I can say else down here, and if they run out of guesses, what I want to do is I want to modify this out of guesses variable. So when they run out of guesses, in other words, when this condition is false, I want to say out of guesses is equal to true. So I'm going to say out of guesses is equal to true. So basically what we're doing down here is we're saying, hey, they're out of guesses. And this is actually what we would call like a flag. So you'll hear people sometimes call these like Boolean flags. And this is basically just a value that's giving us a piece of information, right? This is telling us that the user's out of guesses. So there's one more thing we have to do in this while loop. You'll notice that this while loop is going to keep executing as long as the guess is not equal to the secret word. But now, since we're adding in the guess limit, there's actually another situation where we're going to want to stop looping. And that situation is when the user is out of guesses. So I want to modify this. I want to say that we want to keep guessing while they haven't guessed the secret word and they're not out of guesses, right? Because if they haven't guessed the secret word, then we want to keep asking them. But if they ran out of guesses, then we want to break out of the loop, right? So I'm going to keep looping while the guess is not equal to the secret word and the user is not out of guesses. So now we have a while loop set up, which is going to allow us to specify a guess limit. So there's one more thing we have to do, which is down here. Now down here, we're basically just saying you win, right? So whenever we break out of the loop, we're telling them that they won. Here's the problem though. So there's two situations now where they could break out of the loop. When the guess is equal to the secret word, in other words, when they guess correctly, but there's also another situation, which is when they're run out of guesses, right? And so down here, we're not gonna be super sure which situation occurred. So what we can do is we can use another if statement and we can check. So I can basically say if, and I can check to see if they're out of guesses. So I can say if out of guesses, if this is true, then I want to print out a lose message. So I'm basically just going to say you lose. But otherwise, if it's not true, that means that they guessed the word correctly. So we can go ahead and put this win message down here. All right, so that is essentially everything we need to do to specify the guess limit. I know this was a lot of code. Why don't we run our program? We'll play the game, make sure we got everything right, and then we can come back and we can kind of go over what we did again. So I'm gonna run the program. It says enter guess. So I'm gonna go ahead and lose the game. So remember, we have 3 guesses, so I can just type in some random guess, another one. Now we're on our 3rd and final guess. If I don't get the word this time, we're gonna lose. So I'm not gonna get it, and I'm gonna click enter, and it says you lose. So it was able to figure out that we didn't guess the secret word in 3 tries, and it told us that we lost the game. Cool. So now let's see if we can win the game. So I'm gonna go ahead and run this program and it's gonna say enter guess. So let's enter 2 wrong guesses. Now we're on our last try. Let's say I have a stroke of genius and I type in the right word and it says you win. So the program is now smart enough to play this game with a guess limit. Let's go over one more time what we did. We created a bunch of variables up here. The secret word is pretty obvious. The guess is just storing what they guessed. The guess count is keeping track of how many times the user's guessed, right? So every time we run the code to allow them to guess the word, we're going to increment it. The guess limit is just telling us how many times they can guess. And this out of guesses variable is basically going to tell us whether or not the user has run out of guesses. So down here we have our loop. And this loop is basically just going to keep going and keep asking the user to guess the word. And it's going to keep doing that as long as the guess is not equal to the secret word and as long as the user is not out of guesses. So if either of those conditions is false, we're going to break out of the loop. The first thing we do in the loop is we basically use this if statement and we say if guess count is less than guess limit. And so if the guess count is less than the guess limit, in other words, if they haven't guessed 3 times in our case, then we're going to prompt them for another guess. But if they have guessed 3 times, then we're going to set this out of guesses variable equal to true, and that's going to trigger us breaking out of the loop. So if we do break out of the loop, there's 2 situations, right? The first situation is that we won the game and we guessed the secret word correctly. But the other is that we ran out of guesses. So down here, I'm basically checking that. I'm checking if we're out of guesses. If we are, that means we lost. Otherwise, that means we won. And so that's the basics of building this program. And I do just want to say, this while loop up here, we used a simple while loop to do this, but you could also run this program using a do while loop. And so if you want a challenge, if you really understand what's going on here and you're pretty solid on what's going on, a good challenge would be to try and build this program with a do while loop instead of a while loop. And it's going to be pretty similar. A lot of the code can stay the same, but there are going to be some key differences that you're going to have to try to account for. So if you're looking for a challenge, try to build this with a do while loop. But otherwise, that's sort of how you build a guessing game. And in this tutorial, we were able to integrate a lot of the stuff that we've learned up to this point in the course, like variables. We used all different types of variables. We used loops. We also used if statements. So hopefully this gives you an idea of how you could build something like this using all that stuff. In this tutorial, I'm going to show you guys how to use a for loop in C#. Now, a for loop is a special type of loop which allows us to keep track of what's called an iterating variable. And basically, this is just a variable that's going to change every time we go through our loop. So basically, it's kind of a situation where we have a variable, and generally that variable will keep track of how many times we've gone through the loop, or it can keep track of other things. But it's sort of a special scenario in our programs where we want to use a loop, but we want to have a variable that's going to be changing or doing something every time we go through that loop. And this is actually really easy to understand. I'm just going to show you guys real quick this example that I have down here. You'll notice that I have a simple while loop. So I said this integer I over here, I set it equal to 1, and I'm looping while I is less than or equal to 5, right? This is a very simple while loop. And every time we go through the loop, I'm basically saying console.writeLine, I'm printing out I, and then I basically saying I++. So a very simple loop. But you'll notice here when I run my program, and I'm going to go ahead and run it right now, that I'm basically printing out this variable I every time I go through the loop. And you'll notice that the first time we go through the loop, I is equal to 1. The second time we go through the loop, I is equal to 2. The third time we go through the loop, I is equal to 3. This variable I is constantly changing every time we go through the loop. And I is actually telling us what iteration of the loop we're currently on. This is pretty cool, right? This variable I is essentially keeping track of the times we've gone through the loop, and we can use this variable I to print that out and to know where we're at in the execution of the while loop. Now, this is actually a very common situation. So a lot of times when we're writing loops in C#, we're going to want to have a variable just like I. A variable that's going to change every time we go through the loop, right? In this case, I is changing every time it's getting incremented by 1. So I is essentially telling us how many times we've gone through the loop. But you could essentially use this variable I to do anything. So instead of just incrementing I by 1, I could increment it by 2, or I can increment it by another value. Basically, the idea here is that we have a variable that we're using constantly as we go through this loop. And it's such a common situation to have a variable like this that there's an entirely separate loop called a for loop, which is designed just for this situation. So down here, I'm going to go ahead and create a for loop, and I'll show you guys how this for loop is actually going to be able to do exactly what this while loop is doing, but a lot cleaner and a lot simpler. To create a for loop, I'm just going to say for, I'm going to make an open and close parentheses and an open and close curly bracket. So far, this is exactly like this while loop, right? It's basically structured the same exact way. But you'll notice in the while loop, inside of the parentheses, I only put one thing, right? I put the loop condition. You'll hear people call this the loop guard, right? It's basically like the condition for when we should loop. Inside of this for loops parentheses, we're going to put 3 different things. So instead of just having one thing, we're going to put 3 things. And the first thing we're going to put in here is a variable initialization. You'll notice up here in my while looping structure, I have this integer I, and over here I'm saying int I is equal to 1. But this is actually outside of the while loop, so I had to do that separately from the actual while loop. Well, in a for loop, I can actually do this same thing inside of this parentheses. So I'm going to copy this, and I'm going to paste it over here. And you'll notice I'm going to leave this semicolon in. So the first thing I'm going to do inside this for loop parentheses is I'm going to initialize this variable I. Now, the next thing I want to do, and you'll notice I'm separating these 2 things with the semicolon, the next thing I want to do is write out my loop condition. So in the while loop, our loop condition is right here. You know what I mean? It's just I is less than or equal to 5, whatever. It's basically like telling us how long we should loop for. I can just take this and I can put this as the second item inside of these parentheses. So now I'm able to take the variable initialization and the loop condition. And finally, I'm going to put another semicolon here, and I'm going to include one more thing over here. And this is going to be a line of code that's going to get executed every time we go through the for loop. Now, if you'll notice up here in this while loop, every time we go through this loop, we're doing something special to this variable. Every time we go through the while loop, we're incrementing I. And this is exactly what I want to do over here in my parentheses. So the last spot inside of my parentheses over here, I'm just going to put in I++. And like I said, this is just going to be a line of code that's going to get executed after every single iteration of our loop. So you'll basically see that I'm doing the same thing over here as I am over here, right? Over here, I'm defining this variable. I'm initializing this variable with a value. I'm doing that down here in the parentheses. Over here, I'm specifying a looping condition. I'm doing that down here in the parentheses. And then finally, down here, after every iteration of the loop, I'm incrementing I, and I'm able to do that over here in this third section. So basically, the for loop is just taking this situation where we want to have a variable that's going to, be used inside the loop, and it's compacting it into this one single structure. And so now I could basically copy this line of code over here, paste it into the for loop, and now these loops are identical. So these loops are actually going to be doing the same exact thing. And I'm going to prove that to you guys. So I'm going to go ahead and get rid of this while loop, and we only have the for loop now. And let's run our program and see what output we get. So I'm going to run the program, and you'll see we're getting the same exact output that we got before. We're getting 1, 2, 3, 4, 5 printed out. So this for loop is doing exactly what that while loop was doing. It's a lot more compact, it's a lot easier to manage, and it's a lot better for us. So let me walk you guys real quick through how this gets executed. Essentially what happens is the first thing we do is we create this variable and we give it an initial value. The second thing we do is we check this condition. If the condition's true, then we're gonna execute all of the code inside of here. Once we're done executing all of that code, then we're gonna go up here and increment I. Then we're gonna check the condition again. If it's true, we'll come back down here and we'll execute this code. Then again, we're coming back up here and we're gonna do that, and then we check the condition again. So it's continuously looping through just like that. And this is the same as that while loop. So you could do what we're doing here with a while loop. It's just that it's a lot more convenient and a lot easier to do it with a for loop. So that's kind of the basics of a for loop. And before I end this tutorial, I wanna show you guys one cool thing we can do with these. Up here, I have this array that I created, and I just kind of commented it out. But I'm going to copy it and bring it down here. And you'll notice this is just an array of lucky numbers. So it's just an integer array, and I have these numbers in here. There's like 4 different numbers. I'm going to show you guys how we can use a for loop in order to loop through and print out all of the elements inside of this array. So I just want to remind you, the way that we can access an individual element in an array is by saying the array's name and then referring to the index of that value. So if I said lucky number 0, this is referring to this 4. If I said lucky numbers 2, this is referring to this 15, right? Basically, that's how we can access an element inside of an array. For loops are really useful. Remember, we have this indexing variable. So I can use a for loop to actually loop through and print out all of the elements inside of an array. So down here, so I actually want to modify a couple of values. I'm going to say int I, instead of setting it equal to 1, I'm going to set it equal to 0, because array indexes start at 0. So this element is element 0 inside of the array. Then I'm going to change this condition. So instead of saying I less than or equal to 5, I want to say I less than or equal to lucky numbers dot length. So this is going to allow me to access the length of the array. So when I say lucky numbers dot length, this is going to tell me how many elements are inside of the array. Then down here, I'm going to say console.writeLine, and I want to print out lucky numbers I. And the way this is going to work is the first time we go through this loop, we're going to be printing out lucky numbers 0, right? Because I is initially going to be 0. So the first time we go through here, we're basically printing out lucky number 0. The second time we go through, I gets incremented, so we're going to be printing out lucky numbers 1. The third time, we're going to be printing out lucky numbers 2, etc. So we can use this for loop in order to loop through this array. And let me show you guys when I run this program. And actually, you know what? I forgot to modify one more thing. So instead of saying less than or equal to here, I'm just going to say less than. And basically, since we're starting at 0, I want to say I is less than lucky numbers dot length. That's because the length of the array is going to be 1, 2, 3, 4, 5, 6. But the last element in the array is at index position 5. So if I say I is less than or equal to lucky numbers.length, then we're going to be trying to access lucky numbers 6 at one point. But the last element is at lucky numbers 5, so we have to say less than. So I'm going to change this back to an I, and let's go ahead and run this, and you'll see that we'll be printing out all the elements inside of that array. So we're printing out 4, 8, 15, 16, 23, 42. So that's one very common use of these for loops, is you can use them to loop through all the elements inside of an array. In this tutorial, I'm going to show you guys how to build an exponent function in C#. So an exponent function is basically a function where we can pass in two numbers, a base number and a power number, and it'll take the base number to the power number. So essentially it's going to, like if I passed in a 2 and a 3, it would give me 2 raised to the third power, right? Or if I passed in a 4 and a 7, it would give me 4 raised to the 7th power. That's essentially what we want to write in this tutorial. So I'm going to come down here below my main method, and I'm actually going to create this function. So I'm just going to say static, and we're actually going to return a integer. So why don't we just have this accept integers? We'll just keep it simple. And I'm just going to call this get pow. So this will basically like get the power, and I'm going to make some open and close curly brackets. And in here, we're going to accept 2 parameters. So the first is going to be an integer base num, and the second is going to be an integer pow num. So we'll basically take the base num and raise it to the pow num, right? So if base num's 2 and pow num's 3, then we'll do 2 cubed, right? It kind of makes sense. So this is going to be a cool little method, and it kind of poses an interesting challenge because we don't know what base num and pow num is, right? If we knew what power number was, for example, if we knew power number was 2, then I could just say base num times base num, right? I could just square base num and we'd be good to go. But I don't know what pow num is, so I don't know how many times I need to multiply base num by itself in order to get the answer. So this kind of poses an interesting challenge. And I'm going to show you guys how we can use a for loop to solve this challenge. So the first thing I want to do is just create an integer, and I'm just going to call this result, and I'm just going to set result equal to 1. And then eventually what we want to do is return result. So we want to modify result enough where it represents base num taken to pow num. Okay? And what we need to do is we need to keep multiplying result times base num pow num times. So let me show you guys. We can create a for loop, and I'm just going to create a simple for loop. And remember, when we're creating for loops, the first thing we want to do is create a variable. So I'm just going to say int I is equal to 0. And I'm going to start this off at 0. And then what I want to do is create a looping guard, so a condition. In other words, we're saying we want to keep looping as long as this condition is true. So I want to keep looping as long as I is less than pow num. And when I say this, this is basically telling C# that I want to keep looping pow num times. So if pow num is equal to 3, we're going to execute this loop 3 times. If pow num is equal to 5, we'll execute it 5 times, etc. And the last thing we want to put inside of this for loop is going to be something we want to do after each iteration of the loop. So I'm just going to increment I. And this is a very, very, very simple for loop. So we're looping through here pow num times. So like I said, if pow num is 2, we'll go through here 2 times. And every time I go through this loop, I basically just want to multiply result times base num. So I can say result is equal to result times base num, just like that. So the first time we go through this loop, result is going to be equal to 1, right? So the first time we go through, result's going to be equal to 1. So now result will be equal to 1 times base num, right? The first time through, result's going to essentially become equal to base num. The second time we go through, result's equal to base num, right? So we're essentially multiplying base num by base num, in other words, base num squared, and storing it inside of this result variable. And we're going to keep doing that through each iteration. So if we go through this loop 3 times, then result is going to have the value of base num cubed. If we go through this loop 5 times, result will have the value of base num taken to the power of 5, right? And then down here, we can just return result. So by using this for loop, we're actually able to figure out what the answer is. So up here inside my main method, let's go ahead and run this. And I'm actually going to print out the answer. So I'll just say console.writeLine, and we're going to write the result of get pow. So why don't we try to do like 3 squared, right? So we'll pass in 3 and 2, and I'm going to go ahead and run this program. So we should get the result of 3 squared, which is going to be 9. And you can see over here we get 9. Now, I just want to point out this this get pow method is only going to work for positive number powers. So we're not going to be able to do like 3 and -2. That's not going to work down here. But we can do positive number exponents. So I could say like 3, 2. Why don't we try like 4 and 3? So this is going to be 4 cubed. So we should get 64. And yeah, we get 64. All right, so it looks like this method's working. So once again, I'll just walk you through what we did. This get pow method accepted 2 parameters, base num and pow num. So the goal was to take base num to pow num. We created this for loop over here, and essentially all I did was I set I equal to 0, and we're going to keep looping as long as I is less than pow num. And what that means is we're going to go through this loop pow num times. So if pow num was 5, that means we went through this for loop 5 times. And every time we went through this for loop, we multiplied result, which was initially equal to 1. We said result is going to be equal to result times base num. So the first time through the loop, result was equal to 1, so we ended up getting result is equal to 1 times base num, so we got base num. Second time through the loop, result was equal to base num. So we said result is equal to base num times base num, essentially. The third time through the loop, result was equal to base num squared. So essentially we were saying result is equal to base num squared times base num cubed. And that's essentially what we did. And that was actually enough for us to get base num taken to pow num. So it's a pretty simple method, although it is a little bit complex because we use this for loop. So what you should do is play around with this method and write it on your own and see if you can really wrap your head around what's going on here. In this tutorial, I'm going to show you guys how to use two-dimensional arrays in C#. A two-dimensional array is basically a situation where we have an array and every element inside of that array is itself an array. So essentially we're building like a little matrix structure inside of our program. And I'm going to show you guys how we can do that. It's actually pretty simple. So if we want to create a two-dimensional array, we can do it just like we would a normal array. So I'm going to create an array of integers, so we'll just say int. And now what I want to do is I want to make an open and closed square bracket. And inside of this open and closed square bracket, I'm just going to put a comma here. And basically this is telling C# that we want to have a two-dimensional array. And I'm going to give this a name, so I'm just going to call this number grid. And I'm going to go ahead and set this equal to something. So now what we can do is we can actually fill this array with a bunch of different elements. So I'm going to make an open and closed curly bracket. And then I'm going to make a new line, and down here we're actually going to be able to populate this array with elements. So if I was making a normal array, I would usually just put in like a bunch of numbers. So I'd say like 1, 2, 3, 4, etc. But when we're making a two-dimensional array, all of the elements inside of this array need to be arrays. So themselves, they have to be arrays. So the first element has to be an array, and the second element would have to be an array, and the third element would have to be an array, etc. All of these elements have to be arrays, and then I could give these values. So I could say like 1, 1, 2, and then down here we could say like 3, 4, and we could say 5, 6. So basically now we have a little matrix of numbers, right? Not only does the number grid have 3 elements, but each of the elements inside of the number grid has 2 elements inside of it. And this is a two-dimensional array. So let's look at how we can actually access some of these elements. What I can do is I can come down here and I'm just going to say console.writeLine. And if I wanted to, like, for example, let's say I wanted to print out this element over here. I can just refer to the name of the array. So I can say number grid. And then I'm going to make an open and closed square bracket. And in here, I'm going to put 2 numbers. So the first number I'm going to put is going to be the element inside of the array. So it's going to be like, this is the first element, this is the second, this is the third, or this is element at index position 0, this is element at index position 1, index position 2, etc. So I'm going to put a 0 because we're trying to access this 1 over here. And then I'm going to put another 0. So I'm just going to put 0, 0. And that's referring to row 0, column 0. Now, when I run this program, it's going to be able to print that out. So you'll see we're printing out 1. We're printing out that element over there. Let's say that I wanted to access this 4 over here. Well, this is going to be row 0, 1. So I'm going to put a 1 right here. And then it's going to be 0, 1. So it's going to be 1, 1. And now when we print this out, we should get a 4, which we do. So that's essentially how you access those elements inside the array. And this works exactly like it does with a normal array. So if I wanted, like, I could modify one of these values. I can do everything that I would do in a normal array. And that's kind of the basics. This is a structure that you might not use all the time, but when you need it, it's extremely useful. And in addition to 2 dimensions, you could also have like 3 or 4 or 5 dimensions. All you have to do is just put more like commas over here. There's also a situation where you might not know how many elements you want to go in there initially, and you could actually just like declare one of these. So I could say like int, and I'll make a 2-dimensional array, and we'll just call this like my array. And if I don't know what elements I want to put in here initially, I can actually just say equals new int, and then over here I need to give this some information. So I would have to say like 2, 3. And this is basically telling C# how many rows and how many columns we want to have. So this would mean there's 2 elements, and then each of those elements has 3 elements inside of it. So that's another way that you could do that. And then you could just manually like insert the elements. In this tutorial, I'm going to show you guys how to use comments in C#. Now, a comment is basically just a special line or block of text in our program that's going to get ignored when we run the program. So comments are really useful for leaving little notes or comments inside of your program. And a comment is essentially just a line of code that's meant for humans and not meant for the computer. And these can come in handy. So I'm going to show you guys basically how these work and what we can do with them. If I wanted to create a comment, I could just come down here and type 2 forward slashes, just like that. And now you'll see that the text in my text editor has changed color. It's now this green color, and that's basically signifying that we have a comment here. So like I said, a comment is a little line or a little block of code that's actually going to get ignored by C#. So when I run my program, anything that I have inside of this comment is just going to get ignored. The comment is for the programmer, so it's for me, or it's for another developer who comes in and is reading my file. So I could leave like a little note here. I could say like a to-do, like, you know, maybe this block of code needs to be done. Or I could even come in here and like describe a line of code. So I could describe this line of code over here. I could say like this prints something out, etc. You could also take these comments and put them after a line of code. So I could come over here and say 2 forward slashes, and you could type out, you know, a comment, whatever. And this is what we call a single line comment. So a single line comment is a comment that can only be on one line. So if I was to make a new line, you'll see down here, this is no longer a comment. And you'll see it's actually throwing an error because the program is trying to render it as actual code. But in addition to single line comments like this, a lot of times you're going to want to have comments that are span multiple lines. One thing you can do is just make multiple lines like that. And you'll see a lot of developers do stuff like that. You can also use a starting and an ending tag. So you can type in a forward slash and a star. And now everything that comes after this forward slash and a star in our file is going to be considered a comment. That is until we end it off with another star and a forward slash. So I can say star, forward slash, and now you'll see only the stuff that's in between these 2 little tags is going to be considered a comment. And these can go on multiple lines. So those are basically the 2 types of comments that we can use. And really a comment is extremely open-ended. I mean, there's no wrong way to use a comment. It's really however you want to use it. And I do want to show you guys one other way these can be useful. So let's say that I'm writing code and, you know, I want to try and run my code without a certain line in it. So maybe I'm like, you know, have a program and I think one line might be causing it to break, or I just wanted to see what it would look like without a single line of code. Well, one option would be to remove that line of code. So for example, I could take this line of code. Maybe this is a line of code that I think is causing my program problems. I could delete it, and then I can go ahead and run the program, right? And then nothing gets printed out. But here's the problem. When I do that, I have to actually like physically remove the line of code. Instead, what I could do is comment it out. So I could just put a comment in front of this, and now this whole thing is basically going to get ignored by C#. So I can run the program, and we're still going to be running it without that line of code, but I don't have to physically delete it from the file. And that just allows me to keep track of it a little bit better. And I can still have it there. It's still taking up space in the file. It's just going to get ignored. So that can be a really useful way. So really, I'd say comments, are basically used for two things. The first is like writing out little messages or notes, either for yourself or for other programmers, or for commenting out lines of code. And you'll see people do both of those, and they're both really awesome. So like I said, comments are pretty much open-ended. You can do whatever you want with them, but I'd say those are the two most common use cases. In this tutorial, I'm going to show you guys how to use exception handling in C#. Now, a lot of times when your C# programs are running, there's going to be certain things that can go wrong. And generally, when those situations occur, C# is going to throw what's called an exception. An exception basically just tells you that something happened in your code that C# couldn't handle. And whenever an exception gets thrown, generally the program crashes. So there's a lot of situations where something might happen in the execution of the program, an exception is going to get thrown, and then the program's going to terminate. And sometimes you're going to want that to happen. Sometimes when an exception gets thrown, you're going to want the program to terminate because you're going to want to know what happened. But a lot of times, especially if you're writing a program that's being designed to run for months and months at a time, you're not going to want an exception to crash the program. In other words, you're going to want the program to be able to keep going when something wrong happens and an exception gets thrown. So I'm going to show you guys the basics of working with exceptions. We're also going to talk about handling exceptions and the different scenarios where an exception is going to get thrown. So down here, I have a basic program written out. And this is a very simple program. Essentially, all it does is it gets two numbers from the user, and it takes those numbers and it divides them. So you see over here, I have console.write. I'm asking them to enter a number. And then I'm taking whatever they entered, and I'm converting it into an integer, and I'm storing it inside of this integer variable. And I'm doing that for both of these numbers. Then down here, I'm just writing out the value of dividing both numbers onto the screen. So there's two major things that we're doing here. The first is we're converting this string into an integer using this convert instruction. And then down here, we're dividing the two numbers. And I'm going to show you guys how we could actually enter in information to this program that will cause exceptions. So let's go ahead and run this. And I'm just going to click start. So over here, I'm going to enter a number. So why don't we enter in a 5? And now I'm going to show you guys one way that an exception could get thrown. So remember, we're dividing these two numbers, and you can't actually divide a number by 0. So just by basic math rules, if we have a whole number like this, it's impossible for me to divide it by 0. So essentially what I'm doing here is I'm asking the computer to do something impossible, right? I'm asking the computer to do something that it's not going to be able to do and it's not going to be able to handle. When I hit enter and I ask the computer to do this, it's going to throw an exception. In other words, the computer is going to be like, hey, I can't do this. Like, I can't divide these two numbers, so the program's going to terminate. So you'll see when I hit enter that this little screen goes away and this exception pops up. So it says exception unhandled, system.divide by 0 exception, attempted to divide by 0. It's basically telling us what went wrong, right? It's saying, hey, you tried to divide by 0. That's illegal. You can't do that, and we can't handle that. So basically, it's throwing this exception. So you can just come up here and click stop debugging, and that'll make that go away. I'm going to show you guys one other way we can break this program. So if I put a number in here like a 4, that's all well and good, right? But remember, we're converting whatever is up there into a number. So if I was to type in like a G, this isn't a number, right? G is not a number. It has no numerical value. So the program isn't going to be able to convert G into an integer, even though I asked it to. So when I hit enter, another exception is going to get thrown. This time, we're getting a format exception. It says input string was not in correct format. In other words, we asked you to enter in a number and you entered in a character. The program can't handle that, so it breaks. That's another example of an exception. So the question becomes, what do we do about this, right? Our program keeps throwing these exceptions, so how can we handle that? Like, if the user enters in a letter instead of a number, I don't want the program to terminate. I want to be able to do something else. Like I want to be able to yell at them and be like, hey, you entered in the wrong thing. I don't want the program to terminate. Or if the user tries to divide by 0, you don't want the program to terminate. You want to tell them that they entered in an invalid number. So if we want to do that, we can actually do something called exception handling. Exception handling is basically the process of catching these exceptions. So we're basically going to tell C# like, hey, there's some code over here that might throw an exception. If it does, we want you to catch it. And instead of crashing, we want to be able to handle it. And I'm going to show you guys how we can do that. So we want to use something called try catch blocks. So I'm just going to type out try and open and close parentheses, curly bracket. And then down here, I'm going to type out catch. And again, an open and closed curly bracket. So try catch blocks work like this. Any code that we think is going to break the program, for example, the code down here, we can put inside of these try blocks. And if that code does indeed break the program, then instead of the program terminating, the program is going to go down here into this catch block and it's going to execute all of the code down there. So what I want to do is take all of my risky code, in other words, all of this stuff, and I can place it inside of these try blocks. So I'm just going to paste it inside of here. So now all of this code that potentially would break the program is inside of this try block. So what I want to show you guys now that I have this catch block over here, I can just do like console.write line, and over here, I'm just going to print out error. So essentially what's going to happen now is if any of this code causes an exception, we're going to come down here and print out this. So let me show you guys. I'm going to go ahead and run this program. And it says enter a number, so let's do the 0 one again. So now I'm gonna hit 0. This should break the program, but now instead of breaking the program and causing an exception, we just print out error. So it's kind of like a backup system. And what we can also do is we can get more information about the error that occurred. So I can say catch, I can make an open and close parentheses, and then I can say exception, and I can just call this E. So I'm basically saying that this catch block is gonna take an exception parameter, and we're going to call it E. If I came over here now, I could basically print out E, and I could say E.message. And this is going to tell me what went wrong. So now when I run my program and we can do that 0 division, I'll say 5 divided by 0, and it's going to tell me what went wrong. It's going to tell me you attempted to divide by 0. If I did the other error, so for example, if I entered in a letter like G, now it's going to tell me input string was not in correct format. So it's able to catch the error that happened, and by saying exception E up here in these parentheses, we can actually get the error message just like that. So this is a really great way to kind of stop our programs from terminating. But here's the thing, there's all different types of exceptions that can get thrown inside of our programs, right? And all I have down here is one catch block. So no matter what exception gets thrown, we're always executing this same code down here. But let's say there was a situation where when the 0 division error occurred, you wanted to do one thing, and when the input error occurred, you wanted to do a different thing. Well, you can't really do that because we only have one catch block. Well, what we can do is we can actually define specific exceptions that we want to catch. So down here, instead of saying exception, I can actually specify a specific type of exception that I want this catch block to catch. So before we were getting a divide by 0 exception, so I can put this in here, and now this is only going to catch a divide by 0 exception. So if I was to run my program and we did the divide by 0, I'll say 5, 0, you'll see it's able to catch it. But if I was to do that invalid format, if I came over here and I said like 6 and then I said a G, it's not going to be able to catch that. So down here, we're getting this format exception, right? And basically it's not being caught because we didn't specify it down here. This catch block is only going to catch divide by 0 exceptions. But what we can actually do is we could make another one. So I could say catch, and in here, I'm just going to type in format exception. And now this is going to be able to catch any format exceptions that occur. So now I could say console.write line, and again, we can just print out like e.message. And so the idea is that instead of just printing out e.message, you would do something different depending on the error that gets thrown. In our case though, we're just going to say e.message. So now when I get that format exception, if I say like 5 and then G, it's going to say input string was not in correct format. So it's able to catch both of those. And that's essentially what you want to do. So what we were doing before is we just had like catch, and we were just kind of catching any exception under the sun. But now we're catching individual exceptions. And this is actually a better way to do it because we're able to account for each of these situations, right? When the user divides by 0, we could print out like, hey, you divided by 0, like watch it. If they have a format exception, then we could do something else. Like maybe we could prompt them to enter that input again, or we could do something else. And so being able to have these multiple catch blocks is extremely useful. There's also one more thing I want to show you guys, which is called finally. So down here, I could just type out finally, and I'm going to make an open and closed curly bracket. And any code that we put inside of this finally block is always going to get executed no matter what, right? No matter what, it's going to get executed. So for example, up here, this code, like if the user enters in an invalid number, like if they enter in a letter here instead of a number, this code won't get executed, right? Because we threw the exception and we broke and we came down here. But sometimes in your programs, even if something throws an exception, you're always going to want to execute something, and that code can go down here in the finally block. But you don't always need the finally block. That's kind of optional. So really, this is just how we can handle different errors in our program. And there's a bunch of different exceptions. If you just go online and search for like C# exception list, you'll find a bunch of these different exceptions. And this really just makes your programs more durable. Like before, this was a very fragile program. If I entered in a letter instead of a number, like it would just crash and burn. But now we're actually able to handle all those different situations using these try catch blocks. So these are extremely useful. And anytime you have code that's a little dicey, especially if you're like getting input from a user, stuff like that, these can come in handy. In this tutorial, I'm going to show you guys how to use classes and objects in C#. Now, classes and objects is actually a big subject, and there's a lot for me to talk about in this particular topic. But this video is just going to be a very basic introduction into what classes and objects are and how we can start using them in our C# programs. Now, in C#, we're going to be dealing with all types of data. And a lot of times when you're writing your programs, you're going to want to work with and represent different things in your programs. And by default, C# gives us a bunch of different data types that we can work with. So in C#, we can represent things like text. So we can use strings to represent text. We can represent characters. We can represent whole numbers with integers. And we can represent decimal numbers with things like doubles and floats, right? We can also represent true and false values with Boolean variables. But here's the problem is with just those limited data types, we're not going to be able to represent or model everything that we'd want in our programs. In other words, there's a lot of things in the real world that can't just be represented using a string or a number or a Boolean, right? I mean, think of something like a phone, for example. Like imagine I wanted to represent a phone inside of my program. Well, I can't represent a phone with like a string. I can't represent a phone with just a number. Like a phone is a complex entity in the real world. And I can't sort of break it down into just one single like string or number, right? I can't represent it using just one of those data types. And that's kind of one of the limitations that you're going to encounter is like you can't represent everything just using one of these data types. So what I want to talk to you guys about today is something called classes and objects. And classes and objects essentially allow you to create your own custom data types. By default, we're given things like strings, numbers, and Booleans, but I could actually create my own data type that would allow me to represent something that I wanted inside of my program. So generally what we'll do when we want to create a data type in C# is we'll create something called a class. And a class is basically just a specification for a new data type. So I could create a class for a phone, or I could create a class for like a water bottle, or I could create a class for a keyboard or a computer. And then I could represent all those different things inside my programs. So classes are basically used to model real world entities inside of our program. So I'm going to show you guys how we can build a class in order to do that. The first step when we want to build a class is you want to open up your Solution Explorer over here. In my case, it's just over here on the right side of my screen. And I'm going to go down to my project. So I'm over here in my draft project. And when I want to create a new class, I can just right click and I'm going to go down to Add. And I'm just going to click New Item. And then over here, we should get this little menu that pops up and it says Class. This is the first one right up here. So I'm going to select that. And then I can actually come down here to the bottom and give this a name. So I'm going to go ahead and name my class. And generally, when we're creating a class in C#, you want to name it with a capital letter. So in this situation, I think we should create a class for a book. So let's say that I was writing a program, maybe this was a program for like a library or a school bookstore, and I wanted to be able to represent a book inside of my program. So I want to create a book data type. So just like I create a string or I create an integer or I create a Boolean, I want to be able to create an actual book inside of my program. So I'm going to create a book class, and I'm just going to call this book.cs, and I'll hit enter. And you guys will see over here that another file has been added to our Solution Explorer. So now we have this book.cs file. And you'll notice that this is pretty much laid out exactly like the other one. So exactly like this program class that we were using over here. And it's basically just like an empty class. So remember what I said, a class is essentially just a specification for, or really it's like a blueprint for a new data type in our program. And one of the cool things about C# is it actually allows us to, specify a custom data type. And essentially what we want to do is we're going to be creating a complex data type. So a string, for example, is a data type, right? And all it is just plain text. A number is a data type, and all it is just, a number, right? We have integers, we have floats, they're whole numbers and decimal numbers. But when we create this book data type, it's actually going to be composed of all of those other data types. So inside of here, we're going to define a series of attributes. And these attributes are basically going to describe what a book is inside of our program. And that's generally what you want to do when you create a class. You're going to take a class and you're going to give it a series of attributes. And like I said, those attributes will kind of define what it is. So I have this book class, and I want to think about what are the different attributes that are going to allow me to represent a book inside of my program. And what I want to do is I want to actually create variables for each of those. So let's think about this. What are the different attributes of a book? Well, I can think of the first one is going to be title. So over here, I'm going to say string title. And before I say string title, I'm going to say public. So I want to say public string title. And I'm actually going to make this lowercase. So that's one attribute that we could store about a book. What's another one? Well, let's think. We would also want to store the book's author. So I can say public string author. And let's just try to think of one more. So I think one more good one might be the number of pages. So I'm going to say public int pages. And all of these different variables that we're declaring over here are called class attributes. And these are essentially pieces of information that are describing what a book is in our program. So I'm essentially modeling the book data type. I'm creating a blueprint for the book data type. I'm saying that inside of our program, a book is going to have a title, an author, and a number of pages. So this is a specification, it's a template. Now what I can do is I can go off to my other program and I can actually create a book inside of my program. So just like I create a string or I create an integer or I create a double or a Boolean, I can create a book and I can store it inside of a variable, and we can actually create something called an object, which is going to be an actual book inside of our program. So I'm going to show you guys how we can do that. I'm going to save this file and I'm going to head back over to program.cs. So this is like the file that has our main method over here. And I want to show you guys how we can create a book now. So if I wanted to create and represent an actual book inside of my program, since I created that class and I defined what a book is, I basically defined the book data type, I can actually do that. And I can create something called an object. And an object is an instance of a class. So when we created the class, we created the template for what a book is. When we create an object, we're creating an actual physical book inside of our program, right? So over here, this class specified like a title, author, pages, right? This is a specification for what a book is. When I create a book object, I'm creating an actual book with an actual title, actual number of pages, and an actual author. So I'm going to show you guys how we can do that. The first thing I want to do is I'm basically going to create this like I would a normal variable. So the first thing I'll do is specify the data type. And in our case, we're going to create a book using the book data type. So just like if I was creating a string, I would say like string, whatever is equal to whatever. Here, I'm just going to say book, and we're going to do the same thing. So I'm going to say book. I'm going to give this a name. So why don't we just call it book 1. And now what I'm going to do is set it equal to new book and an open and close parentheses. And this is how we can create what's called a book object. This is essentially an instance of a book. So this is like a physical book inside of our program. So the class is a specification. The class tells us what the book data type is. An object is an actual instance of that class. All right, so hopefully that makes sense. So now I've actually created this book called book one. And we can use book one over here just like a variable. I mean, it's essentially just a variable that's storing a book object. So remember, the book has all of these attributes, right? So a book can have a title, a book can have an author, and a book can have a number of pages. So when we create our book, we want to give it all of those attributes. So what I can do is I can say like book one dot, and now I can access the attributes. So I could say book one dot title, and I can actually give this a value. So let's say that we wanted to create an object that would represent one of the Harry Potter books. So I could say book one dot title is equal to Harry Potter. So now the title of my book is going to be Harry Potter. Let's come down here and we'll say book one dot author, and the author of the Harry Potter books is J.K. Rowling. So I'm going to say book one dot author is equal to J.K. Rowling. And then finally down here, we're going to say book one dot pages. And let's just say that this Harry Potter book has 400 pages in it. So what I did was I created a book object, which is an instance of the book class, and I was able to define all of the pieces of information about this book. So I defined what the book's title was, I defined what the book's author was, and I defined how many pages the book had. And so now what I can actually do is I can work with this piece of information. So I could say like console.writeLine, and over here I could print out some attributes of the book. So I could say like book one dot title. And now when I run my program, it's going to print out the title of the book we just created. So it should print out Harry Potter. I could do the same thing for the other attributes. So I could say like book one dot pages. And now we're going to print out however many pages book one has. So we're going to get 400. So essentially, I'm creating here a book, right? I defined the book data type in that class, and now I'm creating an actual book inside of my class, which we're calling an object. And what's cool about these objects is I can create as many objects as I wanted. So I could come down here and I could actually make another object. So I'm going to copy this guy, and I'm actually going to paste it down here. And instead of being book one, I'm going to change it to book two. So this is going to be book two, book two, book two, book two. So let's start giving this some different information. Let's say this object is going to represent one of the Lord of the Rings books. So I could say Lord of the Rings, and then the author is Tolkien. And let's say the Lord of the Rings has like, I don't know, 700 pages in it. So now I have a book up here called book one, which is representing the Harry Potter book. And then I have another book down here, book two, which is representing the Lord of the Rings book. And I'm actually able to have an actual book in my program, right? So I'm able to represent and store and work with and model a book inside of my program. So down here, I could do the same with book two. I could say like book two dot author. And now this is going to print out the author of book two. So you'll see over here, we get Tolkien. Now, I want to bring up one point. So both of these objects are books, right? Over here in this book class, I defined the book data type. I basically told C# like, hey, we got a new data type. It's a book. It's awesome. All books have a title, an author, and a number of pages. And over here, I created individual books off of that blueprint, off of that template, right? So book one is its own book. It has its own title, its own author, and its own pages. Book two down here is another book, and it has its own title, its own author, and its own pages. So if I was creating an application for like a library, for example, let's say the library had 10,000 books. Well, I could create 10,000 objects, all of which would have the title, the author, and the number of pages of each one of those books. And then I could work with those books. I could pass them into methods. I could use them in if statements. I could do all sorts of stuff with those books, just like I would with other data types like strings, numbers, or Booleans. So classes and objects are extremely powerful. And really, this is just scratching the surface. This is like lesson one. This is the bare basics of working with classes and objects. As we go forward for the next few videos, we're going to learn all sorts of ways to make these a lot more powerful. In this tutorial, I want to talk to you guys about using constructors in C# classes. Now, a constructor is basically a special method that we can put inside of a C# class, which is going to get called whenever we create an object of that class. So anytime I create an object of a specific class, the constructor method will get called and we can do different things. So I'm going to show you guys how we can leverage that constructor method in order to make it a lot easier for us to create objects off of the classes that we create in C#. So down here, if you're not following along with the course, I basically created a class over here called book. And I just created this book class, and I basically said that the book is going to have a title, an author, and a number of pages. That's kind of all this book is. And then over here in my program.cs, in my main method, I created two books. So I created a Harry Potter book, and I created a Lord of the Rings book. Now, I want to show you guys how we can use a constructor, and we're actually going to be able to use a constructor to make it a lot easier for us to create these objects. But before we do that, I just want to give you an introduction to what constructors are and kind of show you what's happening. So over here in my class, I'm actually going to create a method. Down here, I'm just going to say public book. I'm going to make an open and close parentheses and an open and close curly bracket. Now, you'll notice that I said public and then I said the name of the class. And this is what's called a constructor. So anytime I make a method like this where I'm saying public and then the name of the class, this means that this is going to be the constructor for this class. And like I told you guys before, the constructor is basically a special method inside of our class that's going to get called when we create an object of this class. So let me prove that to you guys. I'm going to come down here and I'm just going to type out console.writeLine, and I'll make an open and close parentheses. And down here, I'm just going to write creating book. Okay, very simple. Now over here in my program, in my main method, I'm gonna run this, and what you're gonna see is every time I create a new book, this line and this line, that is gonna get executed. So I'm gonna run the program, and you'll see over here it says creating book and creating book. Essentially what's happening is when I come down here and I say new book, what I'm doing here is I'm actually calling that constructor method. So this right here, this line where I'm saying new book, this book is directly linked to this method over here. And again, I'm going to prove this to you. So over here, what I'm going to do is I'm going to say that this book method, this constructor, should accept one parameter. So I'm going to say string name. That's all I'm going to say. And then down here, I'm just going to print out name. So this method is accepting one parameter, name, and then down here we're going to print it out. Now over here, you'll notice I'm already getting errors, and that's because I didn't include a parameter. So I could come over here and say like Mike, and then down here we could pass another name like John. So now when I run my program, it's going to print out Mike and it's going to print out John because I'm calling that book constructor. Awesome. So not only does this call that constructor, but from here we can also pass parameters into that constructor, and that is extremely powerful. So I'm going to show you guys what we can do with that information. Now let's talk about the code that we have over here. You'll notice that I have a bunch of code here. So when I created this Harry Potter book, it took me 4 lines of code, right? When I created this book 2, this Lord of the Rings book, it took me another 4 lines of code. Total of 8 lines of code just to create 2 objects, right? Just to create 2 books, I had to write out 8 lines of code. Not only that, I had to manually type out book1.title is equal to Harry Potter. Book1.author is equal to J.K. Rowling. Like, that's a huge drag. You know, having to do that every single time we want to create a book is extremely annoying. And imagine if we were, instead of creating 2 books, we were trying to create 10 or 12 or 20 books. Right, it would take forever because we'd have to manually go through and, you know, assign a title and an author and a number of pages. So this is a totally valid way to create our object and give it some attributes, but there's actually another way, and we can use that constructor to do it. So essentially what I want to do is I want to allow the caller to pass in a title, an author, and a number of pages into this book constructor. So when they create the book, I want them to be able to tell me what the title is going to be, what the author is going to be, and what the number of pages is going to be. That way, they can just tell me right away, and I can handle it up front, and then I don't have to say like book1.title is equal to whatever, and book1.author is equal to whatever. So let's see if we can wire that up. Over here, again, this book constructor is going to take in 3 parameters. And we already saw before that over here, we can pass parameters into here, right? So I can pass a parameter into here and it's going to get passed into that constructor. So I'm going to say that this constructor is going to take 3 parameters. The first is going to be a string, and I'm going to call this a title. And this is going to stand for argument title. And you guys will see why I'm naming this differently in a second. And then I'm going to make another string. I'm going to call it a author. And then I'm going to make an int, and I'm going to call it a pages. Now, essentially what's happening is whenever we create a book, we need to pass in the title, the author, and the number of pages. And so what I can do now is from inside of this constructor, I can just come down here and I can say title is equal to a title. And basically what I'm saying is this title up here, the title of the object, is going to be equal to the title that they passed in. So whenever we create a new book now, we're going to pass in a title. And down here, I'm going to say that the title of the object is going to be equal to a title. And so now instead of having to say like book1.title is equal to whatever, now I can just pass the title in over here and I'll just assign the title from over here. So essentially doing this is the same as saying book1.title is equal to whatever. It's the same exact thing, except I can just do it straight from in here. So what we want to do is do this for each of these attributes. So I can say author is equal to a author, and then we can say pages is equal to a pages. And I just want to point out, you can name these whatever you want. So I could even name this title if I wanted. Or I could name this, whatever. It doesn't matter. I'm just using a title because it kind of shows that this is the argument that got passed in, and it kind of distinguishes it from the actual attribute of the object, but you can name it whatever you want. All right, so now when we go back over to our program, you notice we're getting errors here, and it's basically saying there's no argument given that corresponds to the required formal parameter. In other words, hey, you need to pass in all this information now. So what I can do is I can take this information from down here and I can pass it into here. So I can pass in the title, Harry Potter. I can pass in the author, J.K. Rowling, and then I can pass in the number of pages, 400. So instead of having to do that manually, I can just get rid of all this. And now we have the same thing. So I'm passing in the title, the author, and the number of pages. And then over here in the book, I'm taking those parameters that got passed in and I'm assigning them to the attributes of the object. And that is super cool and super useful. So let's do the same thing for Lord of the Rings. We can copy this, I'll paste this bad boy up here. So I can get rid of all of this stuff now. And essentially we have the same exact thing. So we went from having 8 lines of code to create these 2 objects to now we just have 2 lines of code, 1 each, and we're passing in all of these different attributes. So this should actually work, and I'm gonna go ahead and prove that to you. So I'm gonna say console.writeLine, and I'm gonna go ahead and just print out like book2 dot, I don't know, title. And so you'll see that this attribute got set. So now I can run my program and we get Lord of the Rings. So it's doing exactly the same thing. Now I also wanna show you, if you want, you can modify any of these values. So I could technically come down here and say book2.title is equal to The Hobbit, and now this is going to update book 2's title. So now when we print it out, it's not going to be Lord of the Rings anymore, it's going to be The Hobbit. So that's kind of how this constructor works. And that constructor is super powerful. It's an amazing way for us to be able to create these objects really quickly. And I also do want to point out that you can have more than one constructor. So I have this constructor book, and it takes a title, an author, and a number of pages. But if I wanted, I could just create another one. So I could say like public book, and this could take no parameters, and I'd still be able to do this. And so now I can have that, and I'll still be able to create a book just by saying book 3 is equal to new book. So now I'm able to create the book like this with no parameters, with no arguments, or I can create the book with a bunch of arguments. So you can create as many of these constructors as you want. And yeah, that's kind of the basics of constructors. These are very powerful. What you want to do is just play around with these, right? I mean, as long as you understand what's going on, like this constructor over here is directly related to me saying book over here, then you kind of like have a good understanding of what these are. In this tutorial, I'm going to talk to you guys about object methods in C#. Now, an object method is basically just a method that we can define inside of our class that the objects of that class can use to either like find out information or modify information about themselves. And object methods can be very useful. So I'm going to show you guys just a little demonstration of how to use them in this tutorial. What I've actually done is I've created another class in my program. So I created this student class over here. And this student class is pretty simple. I just defined 3 attributes that are going to be part of my student class. So every student is going to have a name, a major, and a GPA. And then down here I have a constructor, so I'm just sort of passing in the name, the major, and the GPA, and I'm assigning them down here. So this is a very simple class, a lot like the class we created in the last tutorial with constructors. So now that I have this student class, I went over to my program and I actually created a couple students. So I had these variables, student 1 and student 2, and then I created these student objects. So one is, his name is Jim, he's a business major and he has a 2.8 GPA. And then we have Pam, she's an art major and she has a 3.6 GPA. So these are 2 objects that I've created from that student class. And I want to show you guys how we can put a method inside of that student class that these student objects can use to find out some information. What I want to do is I want to be able to figure out whether or not each of these students is on the honor roll, right? So let's say that we're, modeling students for a college or university, and the rules at that college are that if you have a GPA of 3.5 or greater, then you have honors. So you're on the honor roll. I want to be able to find out whether or not Pam and Jim are on the honor roll really easily. So one way I can do that is by creating an object method. So what I'm going to do is I'm going to come over here to my class, and down below this constructor, I'm going to create a method. So I'm actually going to create a method that is going to tell us whether or not the student has honors. So I'm going to come down here and I'm just going to say public, and I'm going to say bool, because we're going to return a Boolean value. Essentially, this method is going to return a true if the student has honors, or it's going to return false if the student doesn't have honors. So now I'm just going to call this has honors, and I'm going to make an open and closed parentheses and an open and closed curly bracket. So inside of here, we can start writing out the code to tell if a student has honors. Now remember, what I said before was if a student has a GPA of 3.5 or above, that means they're on the honor roll. So what I can do is I can just use a simple if statement, and I can just say if, and I'll come down here and I'll just say if GPA is greater than or equal to 3.5, then I'm going to come over here and I'm basically going to return true. So I'm just going to return true. And if that's not the case, then I'll come down here and we'll just return false. So in the case that the GPA is greater than 3.5, we'll hit this line of code, which is telling us to return true, and we'll exit the method. And if this is false, so if the GPA isn't greater than 3.5, then we'll come down here and return false. So this is obviously a very simple method, but it's going to come in handy with our objects. So I'm going to head back over here. And basically what I can do now is I can figure out whether student 1 or student 2 is on the honor roll. So I could come down here and I can just print this out. So I'll say console write line. And what I want to do is I want to print out whether or not each of these students has honors. So I'm actually going to copy this and I'll come over here and I'll say student1.has honors. And then we can also say student2.has honors. All right, so I'm printing out if whether or not student 1 has honors, and I'm printing out whether or not student 2 has honors. Now, what should happen is student 1.has honors should return false because Jim has a 2.8 GPA. Jim's not that smart. And this line down here, student 2.has honors, should return true because Pam has a 3.6. Pam's pretty smart. So let's go ahead and run our program and we'll see what happens. So you'll see over here, we got exactly what we thought we would. We got false and true. Now, one of the cool things about the method that we wrote over here in this student class is that this method is actually going to use different information depending on what object is calling it. So when the gym object calls it, when student one calls it, it's going to use Jim's GPA. So when Jim calls this method, it's going to use Jim's GPA of a 2.8. When Pam calls this method, when that Pam object calls it, it's going to use Pam's GPA of 3.6. So we can specify one method here. We only need to write it one time, and the different objects will be able to use it, and they'll be able to use it with their own information. So Jim calls this method and uses his GPA. Pam calls this method and uses her GPA. And that's why these methods can be so powerful, because we can define one method and then different objects can use it, and they can get different information back depending on the value of their attributes. Another cool thing about this method is if I ever wanted to change the qualification for honors, so let's say that I wanted to change honors from being 3.5 to being 2.5. So now I'm saying any student who has a 2.5 or above can have honors. Well, now I only had to change the code right here. And when I run this program again, now they're both going to have honors. So that value is going to be automatically updated for both of these objects just by changing it in that one spot. And that's what's so powerful about these methods, is they basically allow me to define different rules for my objects. So like I can define what it means to have honors in my program, and I could change it around if I want, and it's not really going to matter because the objects are just calling this method and it's telling them whether or not they have honors. So that's why this is useful. And in the next couple videos, we're going to be looking at some other ways that we can use some methods just like this. But basically, all you need to know is that you can make as many of these as you want, right? So I can make a method over here that tells me whether or not, a specific rule, so that it could tell me whether or not the students have honors. I could also make a method that would modify one of these values. So nothing is stopping me from coming in here and saying GPA is equal to 90.4, right? I could modify each of these students' GPAs if I wanted to. You can basically do anything you would do in a normal method. So play around with these. I'm sure you can think of a couple different, methods that you could create inside of your classes. They can be really awesome. In this tutorial, I'm going to talk to you guys about using getters and setters in C#. Now, a getter and a setter are basically two types of methods that we can define inside of our C# classes, which will essentially control the access that people have to the attributes of those classes. And essentially what this does is it kind of like makes your classes more secure. So it kind of allows you to define what data is valid for specific attributes and what data isn't valid. And really getters and setters are extremely useful. And there's a lot of different scenarios where you want to use them. In this tutorial, I'm going to show you guys one specific scenario. We're going to talk about how to set these up and essentially just how they work. So what I've done in preparation for this tutorial is I actually created another class. It's this movie class over here. And this movie class is very simple. It's basically just modeling a movie inside of our program. So this is sort of the template for the movie data type. And I said that every movie is going to have a title, a director, and a rating. And then down here, I created this constructor where I basically passed in a title, a director, and a rating, and I assigned all of those values. So this is a very simple class. And like I said, it's just modeling a basic movie. And then over here in my program, I created two movies. So I have one called Avengers, and it's just The Avengers with director Joss Whedon, and it's PG-13. And then we have Shrek with director Adam Adamson, and it's rated PG. So pretty simple program, right? We're basically just creating a couple different movies. But here's one of the problems that we actually have with this program. And it might not be super obvious right away, but the problem has to do with the movie rating, right? Now, generally, when movies have ratings, they can only have specific ratings, right? So if we have a movie, generally, it's only going to be able to be G, PG, PG-13, R, or NR, right? And maybe there's some more ratings, whatever. But let's just say that these are all the valid ratings that we can have for a movie. So a movie can either be rated G, PG, PG-13, R, or NR for not rated. And let's say that we want to enforce these rules inside of this movie class. So we want all the movies in our programs to only be able to have one of these ratings. And it can't have a rating other than the ones that I specified down here, right? Well, the problem is, how do we enforce something like that? Right, because what I could do is I could easily come over here and change the rating of Avengers to dog, for example. And now if I was to come down here and print out the Avengers rating, for example, if I came down here and said console.writeLine Avengers.rating, when I print this out, it's actually going to print out the rating. So it's going to be able to print out dog. So dog was the rating that we gave to it. But dog isn't one of the valid ratings down here. Another thing I could do is, even if I set this to PG-13 over here, so if this was like set to PG-13, I could still come over here and manually set it. So I could still say like Avengers.rating is equal to, you know, dog over here. And it's going to be the same scenario, right? I'm still able to set this value equal to dog. So what I want to show you guys is how we can prevent this from happening. In other words, how can we make it so that the only possible ratings for the movies are one of these 5 ratings that I defined down here. And we can actually use something called getters and setters. And in order to use these getters and setters, we're going to have to modify a couple things. So the first thing that we want to do is we want to close off access to this rating property, this rating attribute. And what I can do is I can actually come over here into my program, and you'll see that all of these attributes are public. So we have public title, public director, and public rating. And I haven't really talked about this too much yet, but public essentially means that these can be accessed by anyone. So any other program, any other code that we're dealing with can access any of these attributes. So public just means it's open to everybody, it's open to the world. But there's actually another modifier that we can put in front of here. And instead of saying public, I could say private. And what this means when I say private, this means that only code inside of this movie class is going to be able to access the rating. So only code that is contained inside of these curly brackets over here in this side of this movie class is going to be able to access this. And you'll see now when I go over to program, I'm getting an error down here. So essentially what this is saying is we can't access the rating because it's private. So because the code over here is inside of the program class and it's not inside of the movie class, it's not going to be able to access the rating. So that's the first step in being able to enforce these ratings, is we need to make the rating field private. So I need to cut off access from anybody else. Now, the next thing I want to do is I want to create 2 things called getters and setters. So we're going to create getters and setters for this rating attribute. And basically what these are going to allow us to do is it's going to allow outside code. For example, the code inside of this program class, like down here, it's going to allow code like this to both access the rating and modify and set the rating. So those getters and setters are going to be really important. And we can define those through what are called properties. And a property is basically just like, it's kind of like a little method, but it's a special method that's going to basically allow us to define a getter and setter. So what I want to do is I can just say public, and I can just say string. And what I want to do is name this. Generally what you're going to do is you're going to name it the same as the attribute over here, but in capital letters. So I'll name this public string rating. And then down here, I'm going to make an open and close curly bracket. And inside of here, I need to define 2 things. Or I don't need to, but I'm going to define 2 things. So I can just say get, and I'm going to make an open and close curly bracket. And then I'm going to say set, and I'm going to make an open and close curly bracket. And these are essentially going to be getters and setters. So a getter is going to allow us to get the rating attribute. You'll notice over here, I'm trying to get this rating attribute by saying Avengers.rating, but I'm not able to do it, right? I can't actually access this rating because it's private. And so the job of the getter is to give me that. So I'm just going to come over here, and inside this get, we're just going to say return rating, and I'm going to put a semicolon there. And so basically whenever we say rating now and we want to get it, it's going to return the rating. Now this setter is going to allow us to set the rating. So it's going to allow me to modify the rating. So if I came over here and said Avengers.rating, and you can already see it's trying to make me use this capital letter, is equal to dog, it's going to yell at me because this is a private attribute. So it's not going to let me do that. And that's the point of this setter. The setter is basically going to allow me to do that. So What I can do in this setter though is I can define a specific rule. So I can basically say like, hey, you can only set this value to be a certain value. And so what I want to do is I want to check to see if the value is one of the valid ratings. And if it is, if the value they're trying to set rating to is one of the valid ratings, then we're going to go ahead and set it. Otherwise, we're just going to do something else. So I want to say if, and I want to check to see if the value that they passed in other words, the value that they're trying to set to rating is equal to one of the valid ratings. So what we can actually do is we can say if value, and value is going to represent whatever got passed in. So value is going to represent whatever they're trying to set the rating to. So I can say if value is equal to, and we're just going to do one for all of these. So if the value is equal to G or value is equal to PG, and I'm going to do this one for each of the valid ratings. So I can just say or value is equal to, and over here we can just put PG13. So I'm going to say PG13, and we're just going to do two more. So value is equal to R, and then the last one is going to be for NR. So then over here I'll say or value is equal to NR. So if it's equal to one of these, in other words, if the value that we pass in is equal to one of these, then we're going to be able to just set that as the rating. So I can just say rating is equal to value. Otherwise, though, I'm just going to set the rating equal to NR. So I'm just going to say rating is equal to NR. So if they add in an invalid rating, in other words, if they add in a rating, if they try to set this to a rating that's not G, PG, PG13, R, or NR, then it's just going to get set to not rated by default. So this getter is going to allow us to get the rating, and this setter is going to allow us to set the rating. But you'll notice that in order to set the rating, we have to go through this if statement, right? And so they can try to pass in whatever rating they want, but if it's not equal to G, PG, PG13, etc., then it's just going to get set equal to not rating. And the reason we needed these getters and setters was because we made this guy up here private. So there's one more thing we have to do in order to make this super secure. In other words, there's one more thing that we have to do to make sure that the rating is only set to one of these values. Up here in my constructor, when I set the rating, right here I'm just assigning it a normal value. So technically the user could pass in whatever rating they wanted over here, and then I'm just going to set it to the rating. But now instead I'm just going to say rating is equal to a rating. And what this means is now we're going to set the rating through this setter down here. When I use this capital R, it's essentially calling this setter down here and setting it that way. So now this is completely secure. And down here, what I can do now is I can set this to whatever I want, and it's going to be safe. So down here I can say avengers.rating, so I'm using this capital R now. And over here, if I wanted, I could pass in an invalid rating. So I could pass in like dog over here. And when I print it out, you'll see that we're going to get NR. So we're not going to get dog, we're actually going to get NR. And that's because we had to go through that setter. And the same goes for anything else. So I could say down here like Shrek.rating is equal to cat. And if we tried to print out Shrek.rating, then we're going to get NR because it's going to get filtered out by that setter. But here's the thing, if I wanted to set this to a valid rating, like if I set Shrek.rating equal to R, now it's going to be able to take that rating because it's valid. So that's kind of how we can use getters and setters. And a lot of times what people will do is they'll create getters and setters for each of the attributes inside of their classes. You don't have to, but a lot of times it can be useful. So what you want to do is just play around with that. And basically these just make your class more secure. So they make it so someone couldn't, for example, give your movie an invalid rating. In this tutorial, I want to talk to you guys about static attributes in classes in C#. Now, a static attribute is basically a special type of attribute in a class which is shared by all of the objects and all of the instances of that class. So a static attribute is technically an attribute that is contained on the class itself instead of on the individual objects of that class. And I'm going to sort of explain to you how this works. Over here in my program, I actually created a class, and it's called Song. And this class basically just models a song in our program. So it's kind of like a blueprint for what a song should be in our program. Songs have a title, an artist, and a duration. And then down here, I just have this basic constructor, which allows the caller to create the object right up front. So over here in my program, I created two songs. One's called Holiday, one's called Kashmir. This is Holiday by Green Day, and I just said it was 200 seconds. And then Kashmir by Led Zeppelin, 150 seconds. So we have our two song objects, and I want to show you guys how we can actually create a static attribute on this song class. So one thing I want to point out is there's these normal attributes that we have over here on this song class, like the title, the artist, and the duration. If I was to come down here and print these out, so for example, I could come down here and I could print out holiday.title. And then right after it, I could also print out Kashmir.title. And if I was to do this, you'll notice that both of these objects have different titles. So the first object's title is Holiday, the second is Kashmir. I could do the same thing for the other attributes. So if I came down here and said holiday.artist and Kashmir.artist, they're gonna have different artists, right? In other words, there's two different values that are assigned to the attributes of those objects, right? So when I create an object in my program, I'm basically allowing it to have its own title, its own artist, and its own duration. So each individual object will have their own title, their own artist, and their own duration, right? Those things are going to differ across all of the objects. And that is what we would consider a normal attribute. But there's another type of attribute which is called a static attribute. And a static attribute is an attribute that isn't unique to each one of the objects. In other words, a static attribute is an attribute about the actual class. So this title attribute, like I said, it's different for each of the objects. So holiday.title and Kashmir.title, those are different values. But a static attribute is going to be the same across all of the objects of a class. In fact, a static attribute is basically just an attribute that we would say is about the class. So let me show you guys basically what this is. I'm going to come down here and I'm going to create a static attribute. And you can create it similar to these ones. I can just say public static. So I'm using this static keyword here. And then I'm going to give it a type. And I'm just going to call this song count. And basically what this variable is going to do is it's going to tell us how many song objects have been created. So I'm just going to set this equal to 0 initially. So I'm giving it an initial value. Now I want to show you guys what we can actually do with this static variable. Because we have this static attribute, I could actually come over here and instead of saying like holiday.artist, I could actually say song.songCount. And I could actually print this out. So I'm going to print this out and you'll see that we should just get 0 because that's what I set it to initially. So unlike the artist, the title, and the duration, the song count attribute is actually on this class. So I couldn't say song.title because title isn't an attribute that's associated with song. And you'll see down here we're getting this error. I couldn't say song.artist because artist is going to apply to the objects of the class, not the class itself. But I can say song.songCount because this is a static attribute, which means it belongs to the class. So that's kind of the difference. And I want to show you guys something that we could actually do. So over here I have my constructor. Right, this is a constructor method. It's a very simple constructor. Anytime that we create a song object, so anytime a song object gets created, this method gets called. It's a guarantee, right? Basically, when I come over here and I say new song, this is me calling that constructor. So anytime we create one of these songs, it's going to get called. So what I'm going to do down here is every time we create a song, in other words, after all this code in the constructor, I'm just going to increment the song count. So I'm going to say song count plus plus. So basically what's going to happen is every single time a song object gets created, the song count is going to get incremented. So let me show you guys how this is going to work. Over here, I'm actually just going to get rid of this guy. And I'm going to copy this and I'm going to go ahead and paste it in between here. So in between the creating holiday and creating Kashmir, we're printing out the song count. So let's see what happens. what we should get is 1 and 2. So basically, when we create holiday and then we print out the song count, one song's been created, so we get a 1 over here. Then we create this cashmere object, and so that song count's going to get incremented again, and here we get 2. So this static attribute is telling us information not about the specific objects themselves, but about the class in general, right? So I can figure out how many objects have been created of the song class, right? How many instances of the song class have been created in my program. But that's not a piece of information that is going to be specific to the holiday object or to the cashmere object. That is a piece of information that's going to be specific to the class itself. And that's basically what a static class attribute is. It's an attribute about the class, not about the specific objects of the class. So it's basically an attribute that we store to kind of give us information about that class. And you can create static attributes. You can create as many as you want, and honestly, they can be really useful. And you'll notice that whenever we access them, we don't say I wouldn't say cashmere dot song count. I'm not going to be able to do that. So we have to access it through the actual class. Now, one thing that we could do is we could create a method. So I could come over here and I could create a method. So I could say public get song count, and actually this is going to return an integer. And then over here I could actually return the song count. So I could say and now we're actually going to be able to access the song count on each of our individual objects. So I could technically come down here and say cashmere dot get song count. And now we'll be able to get the song count off of one of those objects. So you'll see now that we can get 2, just like we did before. So you can either just create a static attribute and access it using song.songCount like I did over here, or you could create a getter method like getSongCount, and then the individual objects could access that. And both of those can be pretty useful. Sometimes you're going to want the objects to be able to have access to those static attributes. But that's sort of an overview of static attributes and really that static keyword. And actually, as we go forward, I'm going to show you some other cool stuff we can do with that static keyword. In this tutorial, I'm going to show you guys how to use static methods in classes. Now, a static method is basically just a method that belongs to the class itself. So a lot of times when we create methods inside of our C# classes, usually those methods will be used on objects. So we could have an object of a specific class, and then that object could use those methods to do different things. But a static method in a class is a method that belongs to the actual class, which means you don't have to create an object of that class in order to use it and access it. And these can be extremely useful, and there's a lot of circumstances where you want to create classes that have static methods inside of them. So I'm going to show you guys basically how that works. Now down here you'll see that I have this little line. It just says console.writeLine, and then over here I'm saying math.square root 144. Right? Essentially what's happening here is there's this class in C# which is called math. And inside of that math class, there's a bunch of these methods. Now one thing you'll notice here, when I went to access this square root method inside the math class, I didn't have to create an instance of the math class. Now normally, up to this point in the course, whenever we wanted to use a class or use any of the functionality that a class described, we had to create an object. So I would have to say math, my math is equal to new math, right? I'd have to create an actual instance of the math class like that. But you'll notice that down here, I didn't have to do that, right? In fact, when I try to create an instance of the math class, I'm getting this error over here. And so down here, I can basically just say math.square root, and I'm able to use this method without having to create an instance of the math class. And this is an example of a static method. So a static method, like I said, it's a method that belongs to the class, which means we don't have to create an instance of the class in order to use it. So I could go ahead and run this program, and we should get back the square root of 144. So we should get back 12. I'm going to show you guys how we can do this and how we could basically create something similar to the math class. So up here, I'm going to create a new class, and you can either come over here, right-click, and go to add and then click new item, or we can also go up here and we can click project and click add class. So I'm going to do it this way, and then over here you can see I'm just clicking on class, And why don't we just call this useful tools? So this is going to be our useful tools class. And you'll see over here that I basically just have class useful tools. And inside of this class, if I wanted to create static methods, all I have to do is come down here and I could just say like public static, and I could create a method. So why don't we create one called say hi, and it's going to take one parameter, so it's going to take a string name, and then we will basically just have this say hi. So it's going to console.writeLine, and we're just going to print out hello name. And actually, whoops, forgot to put a return type here. So this should be void. So public static void, say hi, string name, and it just prints out hello to whatever name gets passed in. Extremely simple method over there. And so what I could do is I could actually come down here and I could access that method directly without creating an instance of the useful tools class. So down here, I can just get rid of this and we could just go ahead and call this directly. So I could say useful tools dot say hi. So I didn't actually have to create an instance of the useful tools class. All I did was just access this method directly. So I could pass in my name like Mike, and now we'll be able to run this method without having to create an instance of the useful tools class. You can see over there, everything's running just fine. Now, this is an extremely useful thing. So what you could actually do is you could create a class over here, and it could just be contained of, these static methods. And that's essentially what that math class is that we looked at before. The math class is basically just a class that has a bunch of these static methods inside of it that are used to do different things. So if you just have a normal class, maybe a class that's modeling some sort of real world entity, you can include static methods inside of there, and then the callers don't have to create instances of that class in order to use them. Another thing you could do is set up a class that is solely designed for this purpose. So for example, that math class is actually what's called a static class. So you'll notice when I tried to create a instance of that math class before, I said like math, my math is equal to new math. I'm not actually able to create an instance of the math class. You'll see I'm getting an error here. And this is because the math class is a static class, which means you can't create an instance of it. But you'll notice with this useful tools class, I could create an instance of it and it's gonna be no problem. So like this is actually like a useful tools object. So in certain circumstances, you're gonna wanna do that. Like you're gonna wanna be able to have a class with static methods that can have an object created of it. But in situations like with that math class, you're not gonna wanna do that. So what you can do is you can come over here and we could just say static class useful tools. And now we're not gonna be able to create an instance of the useful tools class. So you'll see down here, I'm getting this error now. Basically says, cannot declare a variable of static type useful tools. And then over here it says, cannot create an instance of the static class useful tools. So that's sort of like two different ways that you can use this. But these static methods are extremely useful. And like I said, there's a lot of situations where you're gonna want to use them basically just to define functionality on the class level instead of on the individual object level. In this tutorial, I'm going to talk to you guys about inheritance in C#. Now, inheritance is basically a technique that we can use in C# where we can have one class inherit all of the functionality of another class. So I can define something called a superclass, and then I can actually create classes that are going to inherit all the functionality from that superclass called subclasses. So I'm just going to give you guys a very basic introduction into inheritance. This is a huge subject and there's a lot that you can kind of get into with inheritance. So I just want to show you guys like the basic concept of what's happening with it. So over here in my program, I created a class. It's called chef.cs. And this is a class that basically like represents a chef in our program. So you can see here class chef. And this chef has 3 methods that it can use. So the first one here is called make chicken. And basically all this does is it prints out the chef makes chicken, right? So the chef can make chicken. The chef can also make salad. So it says the chef makes salad. And the chef can also make a special dish. So it just says the chef makes barbecue ribs. So this is a pretty cool class. It's obviously a very simple class, but it's it can basically represent a chef in our program. So down here in my program.cs, in my main method, I created a chef object, and it's just called chef. And then I basically just said chef.makeChicken. So I'm telling the chef to make some chicken. And when I run my program now, it's going to say the chef makes chicken, right? So hopefully that makes sense. I just have this chef class over here, and I defined some methods in there, and then I created an object of the chef class and told it to make chicken. Now I want to show you guys how we can use inheritance to make another type of class. So let's say that in addition to having just a normal chef like we defined over here, I also wanted to have a more specialized type of chef. So I wanted to represent not only just a general chef in my program, but also a more specialized chef. So let's say I'll come up here and I'm going to say project, add class, and I'm going to create a class called Italian Chef. So Italian Chef is not just going to be a normal chef. He's going to be a Italian chef. And I'm going to go ahead and create this class. So you'll see over here we have this class Italian Chef. Now, let's say that this Italian chef can do everything that the normal chef could do. Right, so this Italian chef is a really awesome chef, and not only can he just cook regular food, but he can also cook like more specifically Italian food. So let's say the Italian chef can do everything that the normal chef can do. So the Italian chef can also make chicken. The Italian chef can also make salad, and the Italian chef can also make a special dish. So the Italian chef is very similar to the normal chef, right? He can do everything that the normal chef can do, and he can also do some other stuff as well. One thing I could do to give the Italian chef all of this functionality is I could just copy and I could paste all of these methods over here, right? And so now the Italian chef is able to make chicken, able to make salad, and able to make a special dish, right? But in C#, there's actually something that we can do in a situation like this. So anytime you have a class like Italian Chef that can do everything and that has all the same functionality and attributes as another class like this chef class, we can use something called inheritance. And inheritance is basically the process of inheriting all of the functionality, all the attributes, etc., from a class like chef into a class like Italian Chef. So what I could do is I could come over here and I could say Italian Chef, and I can make a colon, and I can just say chef. And basically what this means is that the Italian chef is going to inherit all of the functionality from the chef class. So now the Italian chef can do everything that the chef class can do. And I'm going to come over here and prove that to you guys. So I'm going to create an Italian chef object. So I'm just going to copy this guy and I'm going to paste this down here. And I'm just going to change everything to Italian chef. So I went ahead and changed this to Italian Chef. It's called Italian Chef, and we said new Italian Chef. And now I'm saying Italian Chef.make chicken. Now, I'm calling the make chicken method on the Italian Chef object, but you'll notice over here in the Italian Chef class declaration, I don't actually have any methods specified. So I didn't specify like a make chicken method or anything like that. But what you'll see is because I inherited all of the functionality from the chef class, I'm actually still able to make chicken with the Italian chef. So when I run my program, you'll see that it says the chef makes chicken, and this is that normal chef. And then down here, the Italian chef is also able to make chicken because the Italian chef inherited all the functionality from the normal chef. And that's kind of cool. So that's basically what you can do if you have like two classes. And in C#, we would refer to chef as the superclass, and we would refer to Italian chef as the subclass. And the subclass is always going to be inheriting functionality from the superclass. So that's just a little terminology. Now, we can actually take this a step further. So let's say that the Italian chef, in addition to being able to make chicken, salad, and a special dish, can also do something else. So we could add another method in here. I could say like public void, and we'll just call this like make pasta. So in addition to making all that other stuff, the Italian chef can also make pasta. So now this chef can also make pasta, and I forgot to put an open and closed parentheses there. So if I was to come over here to my program, I could say Italian chef.make pasta, and the Italian chef is going to be able to make pasta. So let's run that. And you'll see over here, he's making pasta. But what you'll notice is this normal chef can't make pasta. So if I tried to make pasta on the normal chef, it's not going to be able to do that. So that's going to throw an error. And that's because we only define make pasta in the subclass, not in the superclass. So that's kind of how that's going to work out. And I want to show you guys one more thing we can do. So you'll notice over here in my chef class, I have this method. It's called make special dish, right? And the chef is making a special dish of barbecue ribs, right? So this chef's special dish is going to be barbecue ribs. But let's say that the Italian chef doesn't want to make barbecue ribs as a special dish. So let's say that the Italian chef's special dish is actually like some other type of dish and it's not a barbecue dish. Well, the problem is when I come over here and I say make special dish and I say make special dish, both of these chefs are going to be making the same special dish. So when I run the program, they're both making barbecue ribs. But remember, I don't want the Italian chef to make barbecue ribs. I want the Italian chef to make something else as their special dish. Well, in a situation like this, I can do something called overriding a method. Overriding a method basically means that I take one of the methods that I've inherited, like this make special dish method, and I override it. So I basically come over here into this Italian chef class and I override the functionality of that method. Now, in order to do this, we're gonna have to do one thing over here in the chef class, and we're gonna have to include this virtual keyword. So you'll notice I already have this in here. So up here on these two methods, it says public void make chicken, public void make salad. But down here on make special dish, I've given it this special keyword, public virtual void make special dish. And when we specify this as virtual, basically that means that this method can be overridden in any subclasses. So when I say virtual, it basically means that subclasses can change the functionality of this method. So I can just copy this method, and I'm just gonna go ahead and paste it down here. And you'll see here I'm saying public virtual void make special dish. But instead of saying virtual here in the subclass, so I'm in my Italian chef class, I'm gonna say override. And this is basically telling C# that we're gonna override the make special dish method from the superclass. And then down here I can change it. So I could say the chef makes, instead of barbecue ribs, why don't we say like chicken parm. And so now when the Italian chef makes a special dish, it's gonna be making chicken parm instead of making barbecue ribs. So let's go over here into our program, and you'll see I'm still printing out chef.make special dish and Italian chef.make special dish. When I run the program, they're printing out different special dishes. So the Italian chef successfully overrode the functionality of one of the methods that it inherited from the superclass. And that is extremely useful. So those are three very core concepts in inheritance. So the first is just inheriting all of the functionality from a superclass. The second is extending that functionality. So for example, in addition to being able to do everything that the normal chef could do, the Italian chef could also make pasta. And then finally, we were able to override one of the functions or one of the methods that we inherited using this override keyword on the subclass and using this virtual keyword on the superclass. So that is sort of the basics of inheritance. And like I said, inheritance is a very complex subject, and there's a lot of stuff that you can do with it. But this is kind of just an overview of essentially how it works. So now you kind of have the concepts down in your mind, and you can kind of go forward and learn more specific ways to use it. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe.